Let's see. Well, I'm not going to start the uptime thing until I actually get a stream with quality options. Hold on. Oh, I think I got it this time. Whew. Okay. So let me start the upstream thing. Start. Now. All right. I think it's running. Adam was too early and I'm too late. Oh, man. I know. I was too late because I was setting up this soldering iron right here. Look at that. And it's very hot, and I needed to be sure that I didn't, like, set it up where it would just fall and burn up the house. So I am going to be working today on building up the power supply, level shifter, and connecting LED strips to my setup here. So I was actually still... I also delayed starting the stream because I was waiting to try to get the OneNote to work. The OneNote Online has been very slow recently. I don't know why, but I actually got it by just waiting it out. Just getting a link. See if this like takes forever to load. I'm pretty sure it'll work though, so let's just paste it there. Yeah, there we go. Okay, it works. So let's get the today command and edit it. Hey, there's someone 5209. How are you doing today? Wrap this. Let me get the link again. Edit com today link. Raimu is not. Is that what I had on a whole yesterday? I didn't even bother doing. Did I even bother doing the link yesterday? I did. I just didn't put it in. Okay, I don't know. What am I doing? Raimu is working. Is attempting to prototype and test out some new LED strips today. Yeah. Today. There's C17R. Greetings, program, and hello, Raleigh Monkey. It's just updating the today command here. All right. Let me get my stream helper set up. Let's see. Sort by last message, ignore bots, and now I can see who is waving to me. So then, say 17R 715209, and Rally Monkey, hello. Me doing some soldering to start off today's work. I don't need this anymore. So the first task I'm going to try to do is construct a power cable. See how this goes. This could go off. This could go well. It could go wrong. Is General Max Suck still serving honorably? Yeah, you saw that. Okay, so I'll switch to. Well, hold on. I think I can do on top replica here. I'm going to select window OneNote, and then I'll just bring over here so you can see. Select region. We're just gonna show this part right now. Done, and then I can minimize this, and then don't show the window border, and then I can switch to the hardware view like that. So this is what I'm going to try to do. Learn how to electrocute myself. Yeah, hope not. Hopefully not. Let me introduce you to some of the tools. This is a voltmeter. It's going to measure the voltage. I'll put that over here. There's the power brick. So I need to practice on aiming at the camera. One end goes into the local grid. The other end is this, if I hold it like that, you can see it. It's a barrel jack. So this barrel jack is going to adapt to this receptacle here to form this Y cable, so I have more than one, because I'm going to end up having two strips at the end. So today I'm going to cruelly butcher the plug-ins here, because I actually ordered the wrong thing. I ordered the plug version of the wire adapter, so it's not going to work. So my idea is to cut these off, get the wires out, and attach little headers to the end, so what the header looks like. Okay, oh, it's not going to focus because I have a manual focus. But these headers, I should be able to then plug into this proto board, these proto boards here, and then safely be able to attach other wires without having to solder, and then measure the voltage and stuff like that. So let's get the brick out of the way. And here goes nothing. I'm going to cut off the end of one of these. There we go. Right at before the strain relief. It's gone. No! Could probably reuse that. Okay, so inside here, actually, if I get the camera configuration out, I can muck with the focus. That'd probably be a good idea, right? Alright, let's muck with the focus on this. So there are two conductors in there, a red and a black. We're going to test to make sure, but I'm pretty sure the red is plus 5 volts and the black is ground. No point of no return, exactly. So I need to get some of the shielding out of here. And I just realized I don't have a very sharp knife, which I need. I'm going to have to go get one. Or I could just pick at the insulation. Or I could use one of these tools to pick at the insulation. Was the camera? No, this is a brand new camera. Hello, from Ski Dog. He had an extra camera he let me have. The Kitty Cam was an older HP camera, which really didn't cut it as far as like focusing and with light and stuff. I should try to show this on camera. I am like just picking away at the insulation here. I just need to get a little bite out of it, and then I can strip it down. No, I'm gonna go get a X-Acto knife. Hold on. No, I'm not gonna do it with my teeth. I'm just gonna hide the camera for a little bit, so I'll get up and go find an X-Acto knife. Be right back. Okay, I don't have my X-Acto knife around. Camera on. So, I'm just going to use this to look at it very closely and cut it. All right, my goofy headgear here. You won't be able to see me do this either. I'm just trimming away insulation to access these conductors. Goofy glasses. All right. Picking away at it. This would be a lot easier if I had an X-Acto knife. And I don't have the camera aimed right, so you can't even see. You're just gonna see me looking goofy for a little bit. That's okay, I don't mind looking goofy. as I fight the insulation on these conductors. Really, I just need to get a grip on them. I can hear you guys chatting. I hear the little pop when someone chats, but I can't read chat right now. My apologies. Wow, the insulation on this wire is really thick. Probably guys are probably telling me that I have something set up wrong. Okay. This is what this is what I got so far. Focus, please. Focus on that. That's what I got so far. I just need to get access to those conductors and I'm going to pull them right out. RoboRaimu, wearing a Google Glass? No, I'm just wearing a magnifying glass. What are you guys saying? Really wonder what's going on when we can't monitor chat? Yeah. Can I actually work on this while... I'd have to get close to the mic. I can put the mic back. Hello. Mrs. Driver is like looking at me staring. Hold on, I'm gonna move the mic back. You won't hear me talk, but maybe I'll lean closer so you can see me work. That's probably enough insulation, right? Nah, I'm doing this safely. I'm just making a little mess of insulation here. Okay, so I got enough insulation off where I feel comfortable stripping those wires down a little bit, and then I'm going to basically solder on these leads. So one for each one. And then I should be able to plug into the proto board. So I have this wire stripper. Let's do this. There's some copper. I see copper. There's some more copper. All right. And it's braided copper, so I gotta twist it. I know I don't have the camera angle set up right. I have on order a camera tripod thingy, or like a little clip that I can aim the camera in at any angle, but I don't have that yet. So you just see I'm just stripping off the ends there. All right. Now the hard part, or the dangerous part, however you want to think about it. let's focus the camera again on here. And I'm going to solder some leads on here. There. Actually, let's have it point the other way. There. So actually, I can pull these wires now to get at to get at more at this. It's lead-free solder, so we're cool. Actually, I just need to cut this a little bit. I don't want to, basically I don't want to cut the copper conductors, but I want to get enough insulation away. That's probably good enough. Good enough for government work. All right. So, the way these work is you just remove the one you want. Like that. And have a single one here. And I'm going to very carefully solder that on, and then I probably need to trim away more of the insulation, and then I'm going to put this black tape around the whole thing. It's like plastic explosive where you cut the cable when Twitch lowers quality. What's this? It's going to be bother 0.2. Why are you guys talking about 911? Call 911 if you see blood. Yeah. No, I'll be fine. I think I'm actually going to strip away more of the insulation, though. So I'll be away from the mic for a second. Okay. Sorry about that. Soldering iron. Here we go. I need to like have this held down by something. So why not the power brick itself? It'll do some early work for me. There we go. What's this? Let me send you the Raspberry Pi. I hope it helps. No, I'm not using Arduino. I'm using a Raspberry Pi, or I'm going to. Okay, here's the very hot soldering iron. And before I actually pick it up again, I'm going to position this exactly where I want it. And I'm not going to try, I'm trying not to touch it with my hands. I should probably be wearing my special glasses for this, right? Yeah, don't scalp cam. I can't even get close enough. I'll go out without mic for a little bit. Actually, you know what I'm going to do first is I'm going to attach some solder to this thing. So it's probably better to just put the solder on the wire, right? This is where 3 hands would come in handy. Where's Adam when you need him? What happens if you touch it with your hands? You get burned. I'm just going to put some solder on this thing. Melt solder. Are you not hot enough? Okay, it just kind of flew away from me. There we go. I don't think my soldering iron is hot enough. Okay. I'm going in, chat. Okay, I just had to put more solder on the thing. When in doubt, put more solder. Okay, I think my soldering iron is just not hot enough. I'm gonna crank it up to 360 Celsius. Stream fails. Okay, this is why I'm not a good hardware guy. The soldering iron wasn't hot enough, and I didn't twist the thing enough. So there's like an extra strand out there. So I'm just gonna repair this wire. I got enough solder on the thing. I just need to get it to glue now. And where'd the pin go? Chet, did you see where it went? That's okay. I got plenty of those where those came from. Hold it down again. Oh, there it is. I found it. You don't have to get all the strands on. I know. I just need to make a huge solder mess is what I need to do. Hold on. Here we go. Attempt number 2. Okay, that looks like a horrible mess to me. Nah, I gotta clean that up. Let's just take it off. Hold on. Can I get the mic closer to this thing? I can. It's probably way out of focus too. Yeah, go away, pin. Okay, now I lost the pin. And I got solder on my desk. Alright, where'd the pin go? Oh, I wish I had a proper setup. I don't. New pin. I should probably have not done this on stream, right? I should probably have just done this separately. Yeah, this is going to be really hard to do. You know what? I could cheat and just put it on this post. Put the post right into the proto board. And solder it down. What could go wrong, right? Bad idea. God, how am I going to do this? I need like a third hand. This is really hard to do with two hands. I'm gonna burn the proto board if I'm not careful. Okay, it's molten. Not sticking though. I get to stick. I got it to stick. All right. That doesn't look so good to me though. You know, what am I doing? I should be wrapping the copper around it and just make a big ball. Shouldn't I? I don't know what I'm doing. More solder. Don't do this at home. Don't do it the way I'm doing it. Okay, I think I got it that time. Okay, chat, you can tell me how awful my soldering job is. This thing won't stay, like, at a 45-degree angle, will it? Okay, tell me how bad this looks. Tell me how bad this looks. And I messed up my, my microphone stand, too. How's that? Want a closer look? Focus in more. There we go. Okay, now I missed a whole bunch of chat. Hey there, Nomad. This is content, yeah. It's me. It's a software guy trying to do hardware stuff. Really, I just wanted that pin there, and then I want to tape around the whole thing, just so that it ends in a nice pin. The problem is I got to do this thing again now with the ground wire. Someone save me. 50% done. Looks nice and shiny. Maybe really good or really bad in between? Probably. So I think what I'm going to do is twist the wire around. I'm just going to leave the focus in a little bit at this level. I think what I got to do is twist the wire around the post and then solder it on. So really I need to oh no, I just lost the pin. It just popped away from me. I have to braid this. I have to twist this braid so that it's one piece of copper and not a whole bunch of little ones. And then I got to break off another pin because the other one flew away from me. All right. And then I'm going to attempt to just wrap it around the post and then I'm just going to solder it together. So hold on. Nope, that didn't work. Hold on. I think I need to strip it a little bit more. Electronics is like dealing with really, really small things that you can't see when you're older. That's what it is. I'm going to strip a little bit more of the insulation off this so I have more copper. Where's my little tool? Here it is. Just a little bit more of the plastic. There. I got that much off. And I'm going to twist it. Where's the optimal place to hold it? Like right around here? Twist it so it's a nice long piece of copper. And then I'm going to, and I need my little magnifying glass for this. I'm going to wrap it around the post. And I dropped it. I found it. Okay, this is really hard to do without small hands, small fingers. It's a lot harder than it seems. I'm like, I'm just going to solder some posts onto the end of these wires. How hard could that be? Okay, how's this look? I think it looks beautiful. I'm going to put some solder on there now. Hold on. See, the thing about hardware is that you're really bad at it for the first few times, and then once you get some practice in, it's like, oh, I can do this. It's no problem. But I haven't touched the soldering iron in years, so yeah, I'm doing this on stream for your entertainment, right? That's what it's all about. Okay, solder right here, and might as well focus it. Although you can't see it very well. Here I'm going to do the intricate solder work, which is put solder blob on the whole thing. It's beautiful, chat. Beautiful. Let me look at it first, and then I'll let you look at it. Oh, I couldn't have done a better job. Okay, so the thing I learned there is it's much easier to wrap a coil around it first, and then put a solder blob on it. So, fix my mic here. Focus on the thing. Look at that. Isn't that pretty? Isn't that pretty nice big chunk of solder just holding that thing on? And then the other one right next to it. Isn't that beautiful? Okay, now I gotta protect it all with black tape without cutting the wire by accident. So I think I need a little bit more insulation removal. I can sort of do this with my fingernails now, because I can just pull it away. Not too hard. And that way I won't accidentally cut the wires I just so delicately attach leads to. Scissors. Where's my assistant? Where's my stream assistant? Ah, there we go. I got a good grip on it this time. There's where I cut it before. Oh, I got a nice cut in there now. I know you guys can't see, but I'll show you what I got in a second. All right. This is sort of an experiment. Oh, look at that. I got it so I can peel it away now. There we go. That's perfect. Okay, now I'm gonna leave the I'm gonna leave some of the plastic there in case I need to pull more off. All right. See, this gives me newfound respect for Oh Bother, because he can do this with a much better camera setup. So there, I've removed more insulation, and I have the wires there, and maybe I should make sure it's good enough. I'm looking at it with the extra lens here to make sure. Then I should probably turn on the light too. Wait a minute, is my light broken? My light doesn't work now. Did it run out of batteries? Oh, nope. Nope, it's just a loose connection. Loose battery connection? Yep. Hit it. There we go. All right. I see the end of it is got solder on it, so that's good enough. The black one's perfect. It's just a solid mass of solder around the post. Yeah, the red one could have been done better. Maybe attach a little bit more solder glue on it. All right, let me do that. It's very hard to do this without 3 hands. Okay, let's see the fine craftsmanship without burning myself. I think it's off a little bit. Sucks that I need this magnifying glass to even see it very well. Okay, it's not pretty, but it's good enough, I think. Oh, that's taken me 45 minutes? 41 minutes to do? Alright. Well, it had to be done. I don't know if I'll do the other one on stream. I'll probably just do it later. Okay, getting some black electrical tape now. Let's get a nice, good piece. Alright. And I guess we'll do the nicely done black one first. Too wide. Let's cut it in half. All right. All right. I'm just wrapping the wire in black tape. Not doing the best job, although I am trying. I'm trying, chat. And do it on camera would be nice for you guys to see. I think I'm gonna go all as far as I can out. There we go. So there we go. There's the ground wire. Now for the power wire. It's hard to do this and do it on with the camera pointed straight down the desk. So I gotta hold it away from myself. This is sort of ugly, but it'll do. I just really want to avoid short-circuiting and burning things up. You know, fire would not be my friend today. So like insulating these 2 wires from each other, sort of an important thing, right? Okay, and then I probably want a little bit more distance between these 2 wires. That would be good. And test them with this thing. Okay. I need my glasses again. Yeah, I got the tape. I got too much. I did the tape badly. Ah, shoot. Actually, I could just Peel it back. This is bad. Okay, I'm gonna redo the tape. To find the end of it. There it is. Roll it back away. Watch, I'd like sever the wire and have to start all over again. No. Okay, I'm gonna discard that. Start over again. Where's the end of that tape? There it is. This magnifying glasses make it a lot better and a lot more goofy for the stream, I'm sure. I'm sorry if this is boring. I gotta get through this. Then we'll get to the more interesting parts. And I'm learning, right? Learning from failure. Another piece of tape, please. Let's make a nice cut along it this time to make it a nice good strip, not jagged. All right. One dropped on the keyboard, but you know it's not the end of the world. Okay, which one is going to be first? How about the black ground wire? Much nicer. In fact, I don't need all this tape. I'm going to cut it shorter. You guys probably can't see this because I have to hold it close to my face. I'm probably bumping the mic and causing stream noise. Oh well, that's how it goes. Drop the scissors. There we go. Okay. That one didn't go so well. Go back a little bit and try it harder. Do it better. Okay, I like it. I'm ready to show it now. Bring the mic back. Focus, show you the brilliant work that I've done. So, nice taped leads. There we go. It only took me 48 minutes. Whew. Thought it was a VR headset at first? No. Let me fix my setup here. Alright. Probably need to fix the focus there. Okay, what did I miss? Who's in chat right now? Wow, develop it. Strothjay, Alex writes codes, ProSam, War Eagle, Flykin, A Squared, Tesladarks, Nomad, Toulouse, Resubaka, hello. Have I tested to see if it works? Not yet. I think that's what I should do now, right? So now, number one thing I know I need to do is test for short circuit. So I'm going to plug the things in. So now they're plugged into the board. See that? How do I hold it so you can see? There. I need to learn how to hold cameras backwards and focus at the same time, which is this little window down here. There. Now I'm going to test for short circuit. Actually, you know what? it would be probably wise for me to have these on separate, like separate them a little bit more. Something like that instead, right? That'd probably be smart, right? The focus knob on my camera settings is so small, it's hard for my mouse to grab it. So now they're on separate posts just in case. Alright, so I don't need this shield, which actually did catch a blob of solder, which I'm happy about. Let's get rid of the little flakes. Don't need that shield anymore. I'm going to attach some wires here, and let's grab this wire. This is power, and this one is ground. And where's my voltmeter? Here it is. Turn it on to ohm meter, so connectivity. You guys can read that, right? It's upside down for you, but nah, it's okay. And I'm going to test what is the resistance between these two. What's it say, chat? It's upside down for you. Well, hold on. I want to be able to read it, at least. Even if chat can't. Problem is, I don't want to read the resistance through my body. Yeah, there's no connectivity between it. If I connect the two together, I get, should say 0.03. Actually, if I hold it like that, you guys can read it. And then I can read it off my own screen. Look at that. So I touch the two leads together, it'll say 0.2 ohms, right? If I connect it through my own body, it's going to be like, what is that, 2 mega ohms? 1.78, 1.76, 1.75 mega ohms. Which makes sense, because the body conducts electricity. Now if I... Problem is like... Well, you know, it would be easier if I just put two posts there. Yeah, let's break off two more of these post things. And I can just put them down, right straight down. There we go. Then I can test, I can hold them together. No connection. There's no short circuit. No short circuit. That's a good thing, right? Alright, so then let's switch it to off for a second. I need to actually plug in the brick, and here's probably the most dangerous part. I'm running electricity through my body. Yes, I was. That's when you measure the with the ohm meter from one hand to another, you're measuring the resistance of your body through from one finger to another. And for me, it was about 1.6 mega ohms. Million ohms. So, which is a good thing, right? I'm not made out of metal. I'm not a robot. I've just proven it. All right. Where'd I put the power cord? Put it somewhere so that I wouldn't forget it. The chat, remember where I put it? It must be here somewhere. Hold on, let me hide the camera and go look for it. I set it down somewhere. Where'd it go? I found it. Here it is. Put the camera back on. Thank you. All right. Most dangerous part. Taking off the... I keep forgetting to hold my what I'm working on in front of the camera. That's maybe one of the most unexpectedly difficult things. So, US power receptacle. This one goes into the brick itself. Right here. I know how to do this. Look, I'm gonna do it. Look, now I just need to plug this into the wall and cause a fire. No, just kidding. Hold on, I'm gonna turn off the camera for a second. I'm also gonna turn off the soldering iron because I don't think I need that anymore today. And I'm gonna move it away because it's very hot. Okay, I've moved away the very, very hot soldering iron so I won't accidentally touch it. I'm back. Okay. Green LED here says it's on. Here's the live end. You ready? Here we go. Here goes nothing. Plugging it in. So far, so good. Where should I rest this so it doesn't go everywhere? Oh, chat is going bananas. 3, 2, 1, boom. The stream suddenly... Actually, this is too long. I'm going to use the little twist tie thing to hold it in place. Again. I took it off, but then I just realized I don't need all of this wire. I just need to stow it somewhere. We hold it like that. There we go. All right. So. Right. Power's coming in on the right there, and then I have 2 posts there to measure it. So I'm going to put it on volts. Going to let you see what the readout says. And here goes nothing. Ground first, then power. What does it say? Oh, it's on AC. It'd be better if it was on DC current, right? .31 volts. Look at that. Got 5.31 volts, chat. Can we include ProSamX in this experiment? Maybe as a resistor between power and LED? No, we wouldn't want to do that. Hold on. Someone opened my window. I need to close it. I'll be right back again. Slam the window shut. All right. I'm alive. Yes, they didn't destroy anything yet. Okay, so we have 5 volts. I just need to arrange this so it's not hogging the table here. So let me think about this. I can undo this and place the brick on the floor. And just do this very carefully. Actually, I'm going to use... Hold on, I need to go get some masking tape. I have it in the other room. I want to use some masking tape to hold this cable in place so I don't knock it and it doesn't pull and yank and break things. So I'll be right back again. Sorry I keep going off camera so much this stream. I'll be right back again. Okay, the trouble with having so much equipment is you forget where you place things. So I have the masking tape now. All right, so I'm looking back in chat and I see 3, 2, 1, boom, smoke. Nobody's died. No, we haven't killed anyone yet. I'm just gonna take a piece of masking tape off of here, just so that it doesn't yank off the table. my delicate power setup here. So I'm just putting masking tape right here so that it's held to the table. Actually, let's move it a little bit. Let's put the power on the right side here, where you guys can see the edge of it. Yeah, that'll be good. That's good enough, right? Make sure this is tight. You don't want it falling off. And then, actually I can use another piece of duct tape, or masking tape. Hey there, Kowalewski. Welcome to my stream where I, a software guy who does hardware badly. I just adapted this power brick that you can't see because it's off camera now. But we have 5 volts coming in to here. And I have the 2 leads separated because I don't like power and ground for 10 amps being so close together. It makes me nervous, you know? And can I hold that there? Yeah. So there, if there's the voltmeter, and we put it back, verify one more time, that go into AC, DC, right? And then one post to the other should be 5.31 volts. Nice. We haven't burned anything up yet. Okay, so the next challenge, bring in the Raspberry Pi here. Raspberry Pi, this is the ribbon cable from the Raspberry Pi, so it breaks out all the pins. And here's the pin out. If you guys wanted to know, here I'll even focus on it so you can read it. Maybe. So we got, from the Raspberry Pi, we got 5 volts. We got 3.3 volts. We have all sorts of interfaces, GPIOs, SPI, PCM. I am going to just use the GPIOs today. So let me get this set up. What I want to do is see a level shifted signal to driving the LED off of the 5 volt supply. That's what I want to see. So without anything blowing up. Ship it. We should be able to shock me. Hello. All right. Let me pull up. Where is it? Pull up the buddy. Put him on screen. You can't really see the buddy. Okay, we don't need this so much. Can I just move him? Yeah, we did that part, right? So I'm going to move that off screen. We don't need him for right now. Close. Out of an abundance of caution, enter my private key while I'm not on screen. And then, I guess I could switch back to this for a second. I am going to remember how to do the GPIOs. History grep GPIO would probably help me out, right? Right, so I need to make sure I have the GPIO set. Sys class GPIO. And I need to export something, don't I? History grep I export. Right, so yeah, echo 18 export. All right, and then ls. So now we have GPIO 18 exposed to software. Current task. I don't have the current task set up right. We did construct the power cable. It's constructed. So next we are connecting the Raspberry Pi to a 3.3 volt to 5 volt level shifter to there we go. That's what we're doing right now. Electrocute streamer. Oh come on, you guys are nicer than that, aren't you? So my little handy diagram here says that GPIO 18 is where it is. Where's GPIO 18? I'm holding it backwards. Okay, it's pin 12, which I had wired up here, right? Yeah, that's what I have wired to the LED right now. Oh, okay. So if I do it that way, I don't want to have the PWM running, do I? PWM. I need to what? I need to disable the PWM. So that was sys class PWM chip 0 PWM. Well, actually, that's probably fine. No, one level above this, right? PWM. Oh no, right, chip 0, and I need to unexport PWM 0. So it's echo. It's up there, right? Echo 0 T sudo T and then unexport. Right. So the LED turned off because it's no longer being driven by the PWM now, right? So now I want to be able to drive it from the LED or from the GPIO directly. GPIO 18. So cat 1 out to value. No, echo 1 out to value. And echo 1 to, or echo out to direction. Why isn't that not working? Cat value? Oh, now echo 1 to value? There, now the LED lit up. Look at that. LED lit up, so it's being driven by the GPIO. And if I measure that, it's probably going to be 3.3 volts, right? Let's measure it. Okay. DC measurement. Do this so that you can see. Anyway, these are tangled. Let me untangle these. Bzzz. One of my best friends would be like that in electronics lab. He would just like all of a sudden say bzzz. Okay, so I have a ground wire here conveniently. Actually, you know what? I don't want a wire. I want a post. Give me another post. I've been butchering my posts all today. That's fine. I have like a couple hundred of these. Give me a ground post right here. All right, and then I can reach over and just touch the other side of the LED. Beep, 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 warning. .25 volts on that being driven on that LED, right? So the objective is to run it through this level shifter. So I have the data sheet for the level shifter, which is this chip right here. And this is it right here. I don't know what that beeping is. I think it's telling me that there's live voltage, which of course there's live voltage because we were just probing it. Okay, I don't need the solder anymore. I probably don't need this cheat sheet either. It's gonna blow, beep beep, though. Okay. Right. So, first thing I want to do, I think, is connect the grounds together. That would be smart. I'm looking for a really long black wire. I have a really long red one. I have a really long yellow one, but I don't have a really long black one that I haven't cut up yet. I guess I can use this short black one. So I just need to connect the ground over to the other ground. Ground to ground, right? There we go. I've connected the grounds, and you guys can't see that. So I've connected this ground wire from the ground of the power brick right here. This this line's ground is now connected to the Raspberry Pi's ground, the 3.3 volt ground. It doesn't really matter which ground you pick, right? As long as they have a common ground, that's important. And then let me connect the ground to the level shifter. So Let's see which pin that is. Let's go to the right page. Okay, there's the right page. Okay, you guys see that? That's channel 1 output enable, channel 1, I think A is input. 1A is input, and then 1Y is output. And there's VCC and ground. VCC, I think, is the 5 volts. Let me make sure I understand this right. Here it is. Let's not show that or that, and then we can zoom in. Right, so it can basically vary from nothing to 7 volts. It's very versatile, right? So, oh, actually no. The recommended operating condition is VCC 5 volts, right? So we want the 5 volts from our power brick to go into the VCC, and but ground is usually is usually what you want to connect first. So the way this is oriented, the ground is over here. So it's rotated. You can think of it from your perspective, it's rotated 90 degrees clockwise from the diagram. Let me get the diagram on the same to show up on top replica again. Select window, this data sheet. And then select region. This part here. Done. And then I can shrink it a little bit and move it up. There we go. So it's rotated 90 degrees. So and hold on, I need to shorten the region here. Done. Okay, so pin 1 is over here on this side, and pin 7 ground is over here, right? The key is this slot thing, so that is on the left. So that would mean that this, I'm being extra careful here. That would mean that that's the ground, so we're going to ground it. Chip is ground, right? And VCC is pin 14 on the other side, so that's the dangerous red wire. I wanted to get the long red wire, and I wanted that to go way on the other side. Let me remove this ground pin. Yeah, we'll put that over here. And this is the dangerous up to 10 amp power. Ready? It didn't break. The red wire is covering my I can use a shorter one. Shorter one will work. Won't it? Maybe. I wish I had a medium-sized one. Let's just be safe and use the longer one. I can actually bring it all the way around like that. There we go. The red wire is connected to the power brick right here, coming in 5 volts. So yeah, I'll use the shorter red one to power the chip now. That's VCC. That's this pin. Okay. If I melt the chip, then that's okay. I got 3 others. All right. So now the level shifter is powered, and output enable is positive. That means I need to also wire the how about a blue one? I need to wire the output enable for channel 1. So that's pin 1 over to power. Actually, hold off on that for a second. Let me connect the input. So the input was this white wire, right? Pull that white wire off, the LED turns off, and I want that to be the input, which is 1A. So that's pin 2 here. And then pin 3 is the output, so that should be 5 volts now. Let me pick another white wire. I don't have a short white wire, so some other color. Actually, I have these wires dangling here I could use. Let's use green, because green is good, right? So here is the 5-volt output from the level shifter, and I'm going to hook it up into the LED. There we go. Now the LED is lit, only a little bit brighter. It should be lit at 5 volts now. Let me test. Oh, you never connect the plus and the minus together. That's bad news. Don't ever do that. In fact, this post is scaring me. Let me move it. Be very, very, very careful with live power. Okay, so here's ground. Why is that post so flaky? Be a non-flaky post. This one just doesn't want to stick in there. How about if I stick it in there the other way? That'd probably be a smarter thing to do. There we go. I just need to be able to touch ground. Touch the ground, right? Okay, touching the ground. And there, what are we reading? 5.2 volts. When I actually am able to touch it, which is hard to do. Because it's falling out of my hands a lot. How come this is just hard to do. The LED keeps turning off too. I must have a... Why does the LED keep turning off? There's a loose wire here somewhere. Loose wire, where are you? It's probably this one. Got solid connection now. Try again. Wait a minute. How come whenever... There's a loose wire here somewhere. Which one is it? Oh, the output enable. Yeah. We need to actually connect the... So if I ground the output enable, LED turns off. If I pull up the output enable, it's turning on. I forgot to connect the output enable pin 1. All right. That would make sense why it keeps turning off. Because when it's tri-stated like that, and the output enable is not connected, then it just floats. It can go up, it can go down, whatever it feels like doing, right? Okay, so there we go. 5.2 volts. There, cool. So not only is it 5.2 volts, it's 5.2 volts with up to 10 amps. So I can drive the LED strip now. So hold on. That means I am let's turn this off. I got the level shifter assembled. It's connected to the Raspberry Pi, and we tested the voltages. So I did all of that. So the last part is the fun part, connecting the strip to the SPI, and I guess we can select OneNote again and select this region over here. Done. Make it bigger. All right. Let's do that without having the cursor show up. Okay. Don't need that anymore. We have our... Oh, wait a minute. I'm going to need to level shift 2 of them, right? So I need a clock and a data for the LED. I should pull up the data sheet for the LED. That's here. The LED strip is a bunch of these in series, right? And so it's VCC, the 5 volts in, and ground on the other side. I think it's flipped around in a different orientation. Anyway, there's a plus 5 volts, there's ground, and what we really care about is connecting the clock and data in to it. Don't forget to update the current test, thank you. So we got the level shifter. Now, I should test the other level shifter output though, shouldn't I? Connecting the Raspberry Pi through level shifter to LED strip. Yes. Okay, we're going to need to look at this later when we get to the software part. Basically, the data we have to send has to be 4 bytes of zeros, and then the data for the first LED. And then if we wanted to, we can have more LEDs. But at the end, we want to... their data sheet says all ones, but I read on a forum about this that you can either use all zeros or all ones. It doesn't really matter. So we'll just stick to the... We'll just stick to the spec for now. I'll do exactly what they say. I'll send one start frame, one LED frame, and then an end frame. And to do that, I'm going to have to modify the test program that I had. So where was that? Right here. So we're not going to... I guess we can keep the GPIO live, right? So we're going to go to... I have this set up Project Spy. And I'm going to use VI. That's right, I can use VI, and that's the wrong file. I need the V of the C file. Okay, so this little test program I downloaded lets you put in whatever you want for a transmission pattern along the serial bus. So this gets clocked out 1 bit at a time through the LED chain, right? So 1, 2, 3, 4, 5, 6, 7. And then... I'm not very good at VI. I want to preserve the original sequence here. Actually, what am I doing? What am I doing? This is C, right? So I can just do this instead. Okay, and then the actual sequence we want to send out is zeros. This is the, what do they call it? The start frame. Do we want to use tabs here? Spaces. Spaces over tabs. So what do we want to send out? What do we want to light the LED? I like green, so which one is green? Green is the second one. And the way I remember this working is this global is the brightness. So let's do FF00, FF00. FF00, FF00, and this will be full green, full brightness green. Do I want to do full brightness for the first test? I don't know. Okay, and then we need the end code. We'll do it by the book. Yank this line and paste it. I don't need all these lines. And I don't need this many codes. Right, this is the end frame. Alright, and then GCC output spy dev test to spy dev test.c. Alright, so if I just run it, I have to run it as root, actually. Alright, I have to do -d dev spy dev 00. Right. So it's showing us what it clocked back in. So if I again connect the data back into itself, I removed that wire. Hold on, I need another wire. This white one will do. So this one is the data out, so I'm going to have it loop back into data in. Run it again. So there's our start code, and then our full strength green on only, and then there's our end code. So that's all we need to send. I guess we can leave the loopback thing just to make sure it works. Okay. We need to shift up. Actually, no, I'm gonna unpull this. Because this is the clock and data, and we need to level shift them, right? So we're no longer going to drive the LED. Goodbye, LED. Instead, I'm going to drive the, yeah, so this is the input, right? Yeah, we don't need the LED anymore. But I'll leave the LED on the proto board for now. Hey there, Endurin. Hardware Raimu, yes. So, I should put this back on the screen, right? That's what we're doing. Right, so I guess we'll do data first. So data needs to be shifted up. So there's the input. And then I'll wire out the clock too. Where was that? This one, right? So I need an output enable for... Oh, I need another blue wire then. I need to also output enable channel 2. So channel 2 was 4, 5, and 6. So that's... 4 is here. And then 5 is the input next to it. So that is, we want the clock to go into that one. Okay. So then all I need left to do, if I have done this right, is I need, it doesn't matter what color I use. This first one is the data. Let's data will be white. I don't know. Actually, if I had another green and yellow, that would be perfect. Let me see if I have them. Yay, success. So this is the level shifted data out. This is the level shifted clock out. All right. So actually it should be driven now. So I should be able to measure AC. It's an alternating current, right? I actually don't know if this will work. If I measure between ground and the clock, what do I see? I got too much stuff on my desk now. This is difficult. Okay, ground. I don't have a solid ground. I hate this. I need a post that will stick in there for the ground. What if I have a whole bunch of posts for ground? I never have too many ground pins. I need to cut off one of these or else it won't fit. Murdering these posts. So 5 more posts on the edge here for ground. So I can touch any of those for ground. And where is it? Here it is. So any of these is ground. And then this one over here is my clock. What are we reading? Oh, you can't even see it. It's off screen. I guess it doesn't, I guess the alternating current thing doesn't read the clock signal. I wasn't sure if it would work anyway. Anyway, we don't need that then. Should get clamps for your instrument? Yeah, I should. I don't have a professional setup. I am a software guy. I don't know what I'm doing on hardware. Hey, but I have this little guy to help me. Look, little rabbit from Minecraft. Okay. So I have data, I have clock, and then I just need power and ground. So I had that wired up, right? I cut those though. Okay, so I need 2 of those special things. All right, these ones that are double-ended, let's just separate them off. Double-ended, so I can, they're double-ended, what do you call them, receptacles for these wires. So I actually have 3 of them here. I just need 2 of them. How about I try to keep them color coordinated? Like red for power and then, I don't know. Gray is as close as I can get to black because I butchered my black one. Gray and red. All right, and then I have these red and black wires. Oh, wait a minute. I didn't want to use these 28 gauge wires for power and ground for the LED strip, so that's why I didn't have this set up. So never mind all that. I actually want to get the LED strip out and then prepare the wires to plug into power and ground. Where'd the LED strips go? There they are. Here they are. So, it's got all 4 things in there. Power, ground, data, and clock. And I even have the color coded correctly, I think. Based off of what I looked at through the microscope the other day. Yeah, clock is yellow, right. Clock is yellow, and data is green. And then the cool thing is they bring out some higher gauge wires here for power and ground. So I want to strip those down and use those. Those lights, these lights are RGB. So I actually have that link ready. No, I don't have the link ready. I have it over here. No, I don't. Not there. I had it here. So I have the link, not that page, this one. This is the LED strip I have, Endurn. So it's Adafruit dot star digital LED, 144 LEDs per meter, and it's 1 meter spools. So yeah, if I'm successful, you guys can't even see that. Sorry. Adafruit dot star digital LED. So every LED has got a microcontroller inside, which basically holds on to 32 bits of data. 24 bits of color and then 8 bits for control, of which 3 are always set high, so it's really 5 bits of control. So 144 LEDs per meter, and there's more information here. Adafruit's actually really good about telling you how to get things, what to prepare for, and how to hook things up. All right, I hope I don't burn it out though. Okay, we don't need this one anymore. Right, so I need to wire the power and ground. So here's the strip, and we'll put this back on the hardware view. Like such a slacker for hook up your LED strip to Arduino Mega for just 4 wires? Why? That sounds fun. Okay, so I'm gonna wire strip the power and ground here. Live on stream. Let's do the ground first. There we go. And the power. These are nice thick conductors. I think I can plug them directly into the proto board and it should be fine. Later, I want to solder these to some kind of board that will have the level shifter on it. So this level shifter and then the power and ground stuff needs to be all like prettied up and connected right. But right now we're just prototyping. So yeah, I should be able to just plug these directly in if I do this carefully. Now, here's the tricky part. Which one's power and which one's ground? Ground first. Oh, it's too thick to put in. Okay. It's too thick. Hold on, I need my glasses. Old man needs glasses. I need to look at this through the little microscope. Let's turn on the light. Yeah, it's stranded. It's just a really thick conductor. I think I'll just wrap them around posts. So, 2 posts. What could go wrong, right? Let's do ground first. I'm not going to bother soldering this. I'm just going to wrap them around these posts. There we go. There's the ground post. Good enough. It's easier to work with these thicker conductors. All right, so I got, can you guys see that? I got 1 post there, and then where's the other one? Right here. So you connect the level shifter so that you can use 3.3. Yeah, so this level shifter is upshifting from 3.3 volts to 5, which is what the LED strip requires for the clock and data. And we also need the 5 volts anyway to drive the lights. So I have this special power supply here, 10 amp power supply, which I spent an hour soldering posts to the ends of to make it easy to connect to the proto board. And oh, I just did the wrong side of this, dang it. I dropped the post there. Oh, thank you for that follow. Yeah, 5 volt, 10 amp. So should be plenty. These LED strips each take about almost 3 amps at full brightness. Thank you for that follow. I appreciate it. Okay, I probably missed a whole bunch of chat. I hope other people are helping out by answering the easy to answer chat questions. But yeah, please tag me if I don't answer your question, because I'm focused on not electrocuting myself right now, and less so on chat. But if you tag me, I will pause and take a look at your message and try to answer it. I'm doing this without glasses, or without magnifying glasses. It's not so hard because it's just mostly just mechanically hard because they're thick wires. All right, now let me do this without electrocuting myself. So ground first, then power, and they're at a great distance from each other, so as not to short. Okay, so the LED strip is wired up to the power, but it's not lighting right now because probably we haven't given it any data. Let me try to orient this so that you'll see the LED lights when they light up, and do this without shorting anything. Okay. That'll work, right? And then the first LED happens to be sitting over here on the voltmeter. Okay, and then, so I think the last part here is to connect the power and clock, and then run the program. You think I'll survive? Yeah, but I don't want to burn anything out. Okay, you guys can see all of the setup now, right? Let me adjust the camera cutoff a little bit because it's cutting it off slightly. Left, let's crop left at 240, maybe 230. Yeah, 230 is good. And then let me unlock the camera and resize it a little bit. All right, that's good. Did I write the program? No, I got it from somewhere. The Adafruit demo talked about it. So that link that I put in before, there is a tutorial including code. I'm using their example code. So their example code supposedly works for the Arduino, I think. No, they had example code for Raspberry Pi, which is what I picked up. Essentially, though, all the program does for the SPI test is write out a sequence of bytes to... you guys can't see it unless I hide the hardware. What it does is it just writes out this sequence of bytes here to a device. So there'll be a... well, they use an I/O control. Yes, they use an I/O control. So they don't actually write... they don't use the write command. They don't use the write OS call. They use the IOCTL, I/O control. But essentially, they set up a buffer with the data to write to SPI in it right here. And then they have another buffer where they read it back and then print out what they read back. So when I run it, if I had the input connected back to the output, I would see the data come back. But I broke the loopback connection, so we don't see that now. All right. This is a moment of truth, I guess. So I got power, I got ground. The ground is commoned. We're also driving the level shifter. So I have these color coded. So I just need to plug them in now. And so I'm going to plug the green wire in first. And I'm going to connect in the yellow wire. So color coding this is important. All right, and then I'm going to run the thing. Oh my goodness, it's really bright. Jeez. Okay, that's one LED and it's super bright. You see that? Okay, I need to turn it off. Actually, what if I just mask it? I put a sheet of paper in front of it. There we go. Actually, I can mute it, but then you can still see it if I had a real piece of paper. Hold on, I'm digging around for a piece of paper. Everything I have within tape. I just want to temporarily put a little piece of paper over it. like that, so you can still see it's on. Well, can you guys still see it's on? I don't know how good the camera is, but it's not blinding me. I guess you really can't see it, can you? You can hardly see it? I can see it. It's super bright. Actually, what if I just shield it from my eyes, but not yours? There you go. That'll work. The other thing I can do is just turn down the brightness. This is so low-tech. There we go. I have a low-tech shield for my eyes. Change the color? Yeah, so changing the color should be pretty easy, right? I just need to change... So what color would you guys like to see? Give me an RGB value. First one to give me an RGB value, I'll plug it in right here. Yeah, 0F0. In fact, let me say that this is full brightness. Full brightness. And this is the green part. Whoops. Oh, what happened? How do you resume again? A stopped thing. It's running. It's FG for foreground, right? There we go. I'm like forgetting my Unix stuff. Oops, I didn't want to mess that up. I dropped a line, didn't I? So it's we'll just type it again. Okay, so the first one someone typed was orange. Orange, okay. So FFAA00 is orange. According to Endorn. Oh, you guys can't even see. I'm sorry. I was like typing the whole time and you guys couldn't even see me type. Actually, I can repurpose this. Select window PyBuddy and then select region, just this region. Done. And then I can go back to hardware, and as long as I keep the window in its correct place, you can still see this, right? Yeah, there we go. All right. And then let me keep that window up and just make another one to Buddy. All right, and then because you don't need to see me running this, do you? Let's see, D, project spy. I just need to make sure I wrote this file. GCC spy dev test. Output to spy dev test. Spy.test.c. Sudo spy.dev test. I need to do a /. Spy dev test device dev spy 1. It doesn't look orange to me. It looks... Oh, no. Okay. The problem is it's driving 2 LEDs. It shifted the green one over. Oops. It's blue because the one next to it is very bright green. Actually, it is blue. It's sky blue. It's very bright. That's not orange. According to this, it is... blue and then green and then red. So we probably need to flip that around, right? I think you meant to say 00AAFF. I think that's what we need. Replace 00 F F. So one problem is that it didn't reset, it shifted it all up. Oh, we didn't have the long enough end frame. That's probably why. There, I fixed it. All right, so then rebuild and rerun it. Okay, the second one, I need to turn off the second one because it's like shifted up. Okay, it is orange, but the one next to it is very bright blue. Let's turn off the second one. That's E0, because the first top have to be 1s, and then everything else 0. That's off. write that. There we go. So there you got your orange light. So yeah, the way it works is there's a start frame, and you don't see it because it's too long now. But if I scroll down a little bit, there at the end there's an end frame, and everything in between is the LEDs in order from the closest to the power supply to the furthest away. So I turned off the second one because I accidentally shifted it over, and then made the first one orange. And let me scroll that up again once. And I can get rid of the off one. Let's actually put that out here. And comment it out. All right. So what color should we do now? Did someone else give me a color? It was just Endurn. Why is EZO not required for the first light? This one is not a... it is E0. It's E0 plus 1F, which is full brightness. So if I wanted to, I can not do full brightness. Let's do minimum brightness, which would be E1. This is the lowest brightness, right? And then write that out. Did I screw it up? Oh, it shifted the blue one up one. Why did it do that? Okay, how do I... That's weird. It should have... I need to turn off the third one now? Let's just insert a whole bunch of off frames. I don't know how I turned on the third LED there. Let's just turn off a whole bunch of them. There. Now it's just that now I can turn off the shield because it's dim enough. Do you understand the global part of the dock? The global part of the dock, I believe this is talking about... where are we looking at the right one there? Right there, in the frame. That is the brightness. They talk about it down here. Okay, let's turn off this. They talk about right here in terms of, where is it? The driving current, the 5-bit brightness adjustment. So there's only one 5-bit value, and it's what they mark here as global. Can I zoom in more to that? Let's turn this off. How come it won't? There we go. So the only 5-bit field here is marked global. Everything else, the 3 bits is always 1. Everything else is 5 bits. I mean, it's not the best data sheet, right? So I interpret there's only one 5-bit field, so I believe it's this brightness adjustment. And it's a current controlled source, I believe. So it's just lowering the current. If I actually measured the current now, I could probably see that it's 1 over 32 of what it would be at max brightness. Yeah, strange to call global. I think it's because they actually copied that part of the data sheet from another data sheet. Yeah, that part right there. PWM, but it's for each chip though. Each chip has a different. Each chip gets its own 32-bit field. So like if I lit up the 4th LED, what am I doing? With a different brightness. Let's and really at that low brightness it doesn't look orange anymore, does it? How about if I make a nice green one way down here at full brightness? Oh, it's blue, isn't it? RGB. No. Yeah, why is it blue? That's definitely blue. Oh, red, green, blue. I'm just dumb. Okay. So you could see there that is it easy to see that? It's hard for me to see, but the first LED is dim and the 1, 2, 3, the 5th one is bright blue. So they each have an independent brightness. Blue, green, red, yeah. Cannot have full bright pure white specified. You can have full bright pure white. That's what I'm gonna do now. I'm gonna blind myself. So that would be oh, that would be all Fs, wouldn't it? Which is confused with an N frame. Maybe that's what they were getting at with the I think that's what they were getting at the other day. That you're supposed to use zeros for the start and end, because this is confusing unless you go all the way down the string. Red is easier to see. They do have all ones for brightness. Okay, you guys can't see that. I keep forgetting. So all ones is allowed. It means full bright white. Now I can't zoom in. There we go. I'm gonna guess based off of what I read earlier that end frame could be all zeros too. Let me test that. Yank, yank, and then paste there. Let's give me some space here. Oops. And okay, the real end frame at all zeros. Let's suddenly, that wasn't off, that's blue. Let's delete that one. Hardware, build and run. It turned it all white, bright white. One, okay, so it shifted it down. I think the final program that I do, I need to write all 144 LEDs. Because right now, in order to turn that one off, I have to write another one. And now I turned it off. No real end frame. The way I understand it is you have to shift out some more bits that don't look like an LED because of the delay in the string. It's kind of complicated. But let me see. I shouldn't need any of these offs anymore, right? Let me see if I can modify these two. Can you guys see that LED, or is it the camera not working very? I guess I can increase it. Half brightness. And let's do green. Oh, I didn't mean to quit. Get it back here. All right. Compile and run. Okay. And I wasn't showing you the code at the time. So half brightness, orange next to green. It's really bright though. I need the shield again. Find LED stuff fascinating. They're so easy to handle, even as a software dev. You can see the result quickly. Yeah. So my whole goal today, I'm almost done actually, is to just get this tested. So the next steps would be to, I guess I can keep it in the proto for a while. I want to light up all the LEDs and make sure it doesn't brown out or burn up anything. How would I know? These wires would get, well, these wires are most of the current is going over here. Can you see that? Did the camera move? Oh, it's covered by this thing. The camera's in the way. I mean, the cable's in the way. So most of the current's going through these two wires here. Power and ground, that straight into the LED strip, right? So those, you guys can't even see that one. Okay, I need to fix this. This is bugging me. Edit transform, we're gonna go to 220, 210, 200. There we go. I don't want to show all my disks because I got some. There's a mess on this desk. So yeah, this ground wire and this power wire here are going to have like upwards of 3 amps going through it. So I don't want it to melt. anything. The rest of the circuit should be pretty secure, right, though, right? Let me stop and re-chat. If you turn the LED strip towards you, it feels like the main light is reflected in addition to the... Oh, I could turn this off. Is that better? It's very bright. It's probably overwhelming the camera. I could turn one on that's further down the strip. What if I do that? So we have a whole bunch that are off. And then one that's on. Like that. You guys can't see me code. So I'm going to put a whole bunch of ones that are off and then the green one. And it didn't do what I thought it would do. It didn't work at all. Oh, I wonder if the buffer's too big. Oh no, I screwed it up. I know what I did wrong. I cut the green off. I have it off, but I didn't put this line down here. Paste. Those two go together. Let's turn the off one off. And then... There we go. So now there's a green one way out here. And then the Endurance orange one at the front there. Actually, that's War Eagle just gave me a good idea. I should probably measure... Can I turn this back on now? Yeah, so you can see one of them is green and one of them is orange. Actually, what if I light one out here too? How many more is that? Maybe 10 more? 10 more offs? Yank, yank. Paste. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's go a little bit more. And then, let's make this one out here blue. Or how about red? Red! Yeah, I don't need the shield. It's not blinding me too much. What if I turn down the brightness a little bit? So a quarter brightness. That's not the one I wanted. I wanted this one. So we have start frame quarter brightness orange, quarter brightness green, and then quarter brightness blue or red. So back to here. YY10P, what's that? Oh, the VI commands, yeah. There we go. Actually, my light probably is interfering with that one. There, is that better? So we got a green and a red one and an orange one at the front. Yank 10x paste. Oh, I see. I don't want to become a VI expert today, though. I'm just happy I got this working. I want to measure current now. So this is potentially dangerous because I have to break the circuit and put the meter in the middle. Let me turn off Endurance LED for now. Turn off that one. What did I screw up here? Oh, delete. Delete. Insert other kind of comment. There, I turned off the orange one. Sorry, Endurance. Put the multimeter wires to the amp mode. Yeah, so there's a mode on this to measure the current. So that is milliamp current mode. DC. Okay. So you have it set up to measure current. You guys can see the reading. And then I can look into OBS and see the reading as well. Alright. I should probably change the current task, right? Current, we've done that. Now we are bonus time, measuring. I can turn this light on, right? That washes out the LED. We're going to be lit by LEDs now. Measuring current draw of LED strip. That's what we're gonna do. Does the meter have 3 holes? No, it's got to go through the meter, this is the dangerous part. Actually, it's not really. Actually, there's a way we could do this safely with the resistor, right? I could just put a resistor in series with it and then just measure the voltage drop across it. So that's probably a little bit safer. A resistor in series, right? So we're measuring voltage again. DC voltage. Yes. I just need to pick a suitable resistor. So let me think about this. I want a very small resistor, right? So there's no big voltage drop across it. Let's do some quick math. So if I have if V equals IR, and so that the voltage drop, right, it's the current times the resistance. So if we don't want more than like a 0.1 voltage drop, then I want to divide by the current we're probably going to read, which is 0.04 amps or so. Then I can't have more than 2.5 ohm resistor. How much are you running through it? It's 5 volts. Right now it should be about 40 milliamps. Yeah, 50 milliamps. So is that right? 2.5? I need a 2.5 ohm resistor in series with it. 0.04 times 2.5 is 0.1 volt drop. I don't want to drop the voltage too much, just a little tiny bit. Hey there, Joe Mega. Sorry, I'm not responding directly to chat because kind of focused on the hardware stuff and not electrocuting myself. So I'm not very good at acknowledging waves today, unless you tag me. Hey there, Manez. Look, I got my LEDs working. I got to think about how I'm going to do this safely. Because I could measure the current, but then I don't know what happens if I disconnect. Actually, why don't we just test it? Let's disconnect the power to the LEDs and see what happens. Okay. Yeah, it and the post ripped out. I need to fix that. Because I didn't solder the wire to the post. It ripped out the little curl. Actually, if I feed it through like I'm threading a needle, it should work, right? I need my glasses for this. Oh, don't short the power. That would be bad. My special glasses. Fix. Put it back on. I ripped it right out. Okay, so I should probably tape that. Just temporary tape, right? It'd probably be a smart thing to do. Yeah, why don't I just do that? I'll temporarily tape that lead that you can't see because it's slightly off camera now. This one right here. That is off camera. Now it's back on camera. I'm gonna tape that. Got a breadboard kit for your birthday last year? All you've done with it is short out and explode some of the LEDs which came with it? You have no... You just don't... You didn't put any resistors in your circuit first. That's the problem. LEDs will draw as much current as you put through them. You have to control the current with a resistor. So, if you had done that, it would have gone a lot better, I think. I'm basically just going to put electrical tape around this just temporarily. Just so that I don't do, again, what I just did, which is rip it right out. Also, it's a little bit safer this way. I actually don't need that much tape. There we go. That's just a little bit of a safer power connection now. Okay, so the idea is measuring current in line here. and needed to set it to DC current. You guys can still read that number, right? And my LED strip just knocked over. There we go. You can still read it. So the idea is to put the meter in series between the actual power and the LED strip, but it's got to stay in there when I run the program. That's the trick. Let's set this up to just light one LED. Where is that? Here. Let's just light up one LED. So that one's off. These two are both off. I have a bunch of buffer lights in between. Don't need that many, actually. Oh no, let's turn the green one on. And then turn the red one off. Right. Okay, and then I'll just get set up to run this. Okay, so how do I do this without it losing power? I need another wire for power. One hand for the pros, one hand for the program. This is going to be tricky. Yeah, I need a third hand. The meter's on, right? Let's go to hardware scene. You guys can see the number there. Okay. Actually, I don't know how to do this without knocking things over. Not really. And this is covering that. You guys can't even see the number. That's better, sort of. I have to with one hand probe. You guys can't even see that. Why is my camera... I guess I can just shift the camera over a little bit. I have to... dang it, let me fix this. Edit transform for second camera. Go to 150. There we go. And I just need to adjust the size of this thing. There we go. All right, so I need to simultaneously touch these two leads, right? This one. You guys still can't even see that one. More wide field view. Let's go to 125. 100. Sure. Okay, I need to simultaneously touch that lead and then touch the black one over there on the left. And current will go through the LED strip and then I have to run the command. So I don't know how to do that with two hands. So this is going to be tricky. I suppose I could plug them into the board here. Yeah. And then plug the probes in at the same time. Okay, let me move this a little bit. Oh, it came right off again. So much for the tape idea. Okay. I'm gonna take off the tape. Professional hardware streamer here. Thing is, I didn't solder the post to the wire. I just wrapped it around, and it just yanks right off. If I do put any kind of force on it. Ugh. Flatten the wire out again. Should use a tool for that so I don't hurt my fingers. More and more I'm thinking the resistor idea is smarter. But I need to find a very low ohmage resistor. Yeah, let's just do that. I need to go in the garage to get a small... No, actually I have it in the tool chest here. I need to find a very low ohmage resistor. Like what I calculated. Like 2 ohms or something like that. Something that I can measure a voltage across and then to guesstimate the current through it. Okay. So, let me just restore this setup. That's the power, that's the ground, this is the power. It's live. So write it out. There's my LED. And turn off this light. Okay, so if I want to put an LED in series, let me find a low ohmage resistor. It actually might be in the garage. These are capacitors, they're not resistors. Never mind, found my resistors. Would a mod please kick that person? Endoran, you still here? I need to find a very low ohmage resistor. How about a 10 ohm? That should be good enough. I mean, I can do it. There we go. I did it. That's 10K. Okay, 30. What's the lowest ohmage resistor I have? I got a bunch of resistors here. Let's find the one with the lowest number written on it. How about 27? 27 ohms it is. Now if I have a 27, let's verify this is 27 ohms. So ohmage. Hey there, Primogen, by the way. How are you doing? Did I put that in the correct setting? Where's the other probe? There it is. Yep, that's 27 ohms, all right. What kind of voltage drop do I expect with 27 ohms? All right, so voltage equals current times resistance. So it would be the current, 0.04 times the resistance, 27 ohms. No, I didn't do that right. I did plus. 0.04 times 27 is going to be a volt drop. Oh, that's too much. But I can put a couple of them in series. I can put a bunch of them. I mean, a bunch of them in parallel, right? Trying to remember my basic electronics. If you put resistors in parallel, you know, I'm not even going to try to do this. Actually, no, I can. I can measure the ohmage after I put a whole bunch of these together, right? That's what I'm going to do. So let's put a whole bunch of these in parallel. $27 ohm. You got the ohm symbol in there too. Hey, look, Firebergen, I got my LED working. Let's reduce the camera brightness so you can see. Oh, you can see it's green. All right, so putting these in parallel would be doing what? putting them all in the same column. Do this in the middle, just with some space between them. It's a Greek character, yeah, it's omega, but it's also used for ohm. Measurement of resistance. In this case, resistance is not futile. Resistance is what I'm going to use to measure the current without having to break the circuit. I just don't want the voltage drop to be too much. It could probably deal with a 0.1 volt drop. Actually probably deal with a lot lower voltage, but you know. Let's see what 4 of these in parallel do. So, let's some leads. Red one and a black one. Black one. All right. Red and black. What do I get? Connect the red to the red and the black to the black. Very smart. You're guessing 7 ohms? It might not be low enough, right? Yeah. It's 7.0 ohms. There you go. Ta-da. Now, what do I get with 7 ohms? What voltage drop do I get? 0.04 times 7. 0.28? It's going to drop below 5 volts. I don't know. It's probably not going to be 40 milliamps, though. I don't know. Let's see what it is. So, then the trick would be to put this in series in... So let's put it in series. So connect ground first. Well, let's flip these over. I want ground to be on my right. There we go. What resistance does one of your jumper wires have? Probably 0. Close to 0. They conduct column-wise. So they conduct in this direction. And there's a break in the middle. Except for the power rails, which are conducting in this direction. So all 4 of these resistors are in parallel because I have the posts in the same columns. So let's be safe and connect the ground first. And if I were to connect this directly to the power, it's going to draw how many amps? At 7 ohms. That would be voltage divided by... So it would pull 0.71 amps. Actually, that should be okay, right? It'll draw 7... Did I do that right? That's the number of amps times the V equals IR. Hold on. If V equals IR, then I equals V over R, right? So 5 divided by 7. 5 volts divided by 7 ohms is 714 milliamps. I just want to make sure I don't blow anything up if I were to connect that straight to power. I don't think I am. So here goes nothing. I'm going to I need to put this in series, which means what? Which means this actually isn't on the ground. I don't want to use black because I'll get confused. Let's use a dangerous color, white. Danger. Let me think about this. If we want to measure it, yeah, we want to measure it between, I guess I could, no, I don't want to touch the ground. I don't want to put it at the ground. I want to put it at the power. So let's unplug the LEDs. And then put them on one side of the resistor chain here. And then the other side into power. Bzzz. And then drive the LEDs. Okay, cool. I got the LED running, and it's, I can turn this off again so you can see the LED. And it's going through my resistor network, which is 7 ohms, right? So all I really need to do is measure the voltage drop across them. If I put it here, you can see it, right? Yeah. So we're measuring voltage now. And we want to measure DC voltage. Right. DC voltage. I just need to measure the voltage across these two terminals. And which one's going to be higher? The right one's going to be higher. So I want to put the red on the right for me is going to be higher. The left is going to be lower, right? So here goes nothing. .7 volts? 0.707, right? Is that what that says? Yeah, 0.707 volts. So how many amps is that? It's 0.707 divided by the resistance, which is 7. So that's 100 milliamps. And what if I turn it off? Turning it off is easy. I just disconnect the circuit. Right? And then connect it again, and then measure it again. This is when there is no current going, when there's no LEDs lit. .684. So it's drawing a good amount of current even though when there's no LEDs on. So we had 0.101. I should have a notebook page for this, right? One LED at, what's the brightness I had on it? Quarter brightness was 101 amps, or 101 milliamps. And then no LEDs on was, what was that again? I forgot. Let's do it again. 684. 0.684 divided by 7. 97.7. Let's round up to 98 milliamps. What happened to my bullet? There we go. What was the light color? It was green. One green LED. Should we do different colors? So I don't think the let me test the theory that the difference between those is what? That's not that many amps, is it? 101 minus 98 is only 3 milliamps. But we had it on 1/4 brightness. Let's do full brightness and see. And really I should order these the other way, right? So it takes 100 milliamps just sitting there doing nothing. And I read that in the data sheet actually somewhere that it has some kind of quiescent current draw. Can you disconnect the ground from the Pi? Not that you are passing current to it, so measure the Pi's power usage. Well, the Pi is completely disconnected because there's a buffer, this level shifting buffer. So this is only between the LED light strip and the power source. Well, if the Pi was drawing power, it would be drawing power independently of this resistor network. This resistor network is in series only with the LED strip, not with the Raspberry Pi. So I think it's measuring just the LED strip. If you want me to be doubly sure, I can disconnect the Pi from it by pulling this wire. Should I do that? Boop. Pi is going to be disconnected from power. So measure it again, right? Measuring it again. I should get the same number. 684. Yep. So it doesn't matter if the level shifter is connected or not. Okay, let's turn it to full brightness. So that's quarter brightness. That's 7 out of 32 is roughly 1/4, right? Really be 8. Should I say that's 7 out of... It's not 32, it's out of 31. 7 out of 31 brightness. 7/31 brightness. Full would be FF. So then build and run. And that's full green. You can't see? Oh, sorry. The code was just to comment out the quarter brightness E7 and put in full brightness FF there. Sorry about that. So this is full one LED, just the green one, at full brightness. What do I read now? And I'm totally tangling my probe wires. This is hardware is harder than software. You have to have steady hands and steady nerves. How come I'm only getting one significant digit now? There we go. 0.78. 0.78 divided by 7. 111 milliamps. So that is one green LED at full brightness. So really I just need to take that number, drop the 1 and add 2, right? So it's 13 milliamps. Can I do this? Aha, there we go. Let it do it for me. The meter okay? I think it is. Connected to itself, it should say 0, right? Yeah. Alright, so let me turn on full white and see what it does. It should triple it, right? So programming again. Instead of green, we're going to do white. White. Now it's all on. Couldn't read the notes. Yeah, sorry. There it is. 3 for green at quarter brightness. 13 milliamps. This is all in milliamps. Milliamps. Because that was our base measurement. No LEDs on. Turn a green LED on at quarter brightness. Got 3. One green at full got 13. Now we're doing one white, which is green plus red plus blue at full brightness in milliamps. Let's measure it. Do you think we get 50? I'm gonna guess we're gonna get 40. I think that's what the spec said. Let's see, what does the spec say? They have these nice tables where they tell you the typical brightest LED output current 20 milliamps. Then again, I am dropping the voltage a bit, right? Just by measure the current, I'm dropping the voltage. All right, let's do it. Let's measure it. It's on, it's blinding me. Do I dare turn on all 144 of these at once? 0.955. 0.955. 0.955 divided by 7. 136. 38. So it's 40 milliamps instead of... So why would the spec say 20? Why would they say 20? I wonder if that's per LED or something. And since there are 3 LEDs, it could be up to triple that. Voltage level. Oh, yeah, I guess we could measure voltage to ground. I need a black wire. Black is ground, right? Oh no, chat, I'm out of black wires. I don't want to get confused about... Oh, here's a black wire. I found it. I have one black wire left. So I want to measure current to ground. So how do I want to do that? I guess just hold the probe. So back to hardware we go. Ground. And then measuring from ground to what the LEDs are getting. 4.3. Ooh, that's not good. Huh. And then on the other side of the resistor network, what are we seeing? It's hard, difficult for me to do this. 5.27. That's right, isn't it? Yeah, so, okay, we're undervolting the LEDs a bit. Does that make sense that if we're undervolting it, we're going below... There's no minimum, it does actually says. How low voltage can this go, then? Yeah, taking about 0.8 volts, yeah. That was the raw number that we read earlier, right? When I read it from here to here. Other way around. Keep tangling these together. There. Shoot, it'd be this way. That's lower and this is higher. Yeah, 0.954 volts. So, yeah, I wonder how low the voltage can go on these LEDs. It says typical 5. They don't actually... Okay, you guys can't see that. It says typical 5 volts for the supply. We're running it lower than that. Like, almost a volt lower than that, right? And, but it doesn't have a minimum. It just has typical. They can go very low. But there's a microcontroller built into there. And I'm wondering, like, how tolerant it is. All right, well. The higher the current usage on the LED strip, the lower the voltage is going to be because of my resistor network to measure it. So that's going to fudge my numbers a bit, right? So sure, it's taking more current, but then measuring the current itself is lowering the voltage on the LEDs, and that could change the amount of current it draws. But it's within reasonable, like within an order of magnitude of what I expect, right? That there's on the order of 100 milliamps just sitting there doing nothing, and then for every white LED I turn on, I get, you know, between 20 and 40 milliamps draw. Turns out your power supply module burned down and does not want to play with you. Cannot even power anything anymore. That's bad. Do you short something out? It could just be a fuse. A lot of these devices have fuses in them. Locate the fuse, replace it. You can get fuses at the hardware store. And brand new. In fact, I should probably put in a fuse into my final circuit, right? In case of short circuit. So something... Instead of this resistor chain, there would just be a fuse, and set to where if it goes past a certain amperage, it would just cut. Or a screw works. All right. Am I done with hardware today? I think I might be. So I've proven that I can drive the LED. Let's see if I can make sure I can turn it off. Actually, I wanted to play around with that. Can I turn it off just by terminating it early? Like... How would I do this? I guess I just have to butcher this. Yeah, what if I just, Oh no, I have to have as many offs as there are ons right now, don't I? Yeah, okay, that's right. So to turn it off, I would put there, and off. Off. Just sending updates over the serial line. Fuses seem okay, but looking at the bottom, you see some scorched lanes in the actual PB. Uh-oh. That means you know what that means? The fuse didn't do its job, man. Page Page 7 of the datasheet shows voltage of about 1.5 and how much milliamps it draws? Really? Seven, you said. Oh, forward current. So, why does the curve go... I don't understand. Why does it go all the way up into the 100? I guess I need to understand what forward current means. It's funny, they give you instructions on how to assemble the box that holds the reels, which holds the chips. Yeah. Yeah, I don't understand what they mean by forward current. I can't read this. Scorching is below the switch to turn it on off, so that might be it. Still, there should have been a fuse in series in the circuit to cut it off before anything burned. I think I'm done measuring power, right? So let me disconnect the power. Take the resistors out. Thank you, resistors. Actually, they're kind of warm. Not hot, but they're a little bit warm. And then carefully take the post off. And repost it so we can play some more. Okay. So, yeah, I took off the resistor network there. This is just my power thing now. Am I done? We did measure the current draw. I guess should we just go all out and have it light them all up? I need to have 144 lines of pure white bright on. What if we ramp it up one step at a time? Oops. There we go. So we don't need the meter anymore, probably. I'm going to take the meter away. You think it'll be 8 amps? This is a 10 amp supply. I would like to measure the current draw at some point. The Adafruit said it should be about, where did they say? They actually had it in their page. What did they say? I guess they say it in their tutorial. Right here, power and connections. Okay, I didn't do this. The 100 1000 microfarad capacitor. I actually have one of those. I should have put that in line. And maybe I'll do that for this test. One of these bad boys. Look at this. Where's my camera focus? There it is. Camera focus. This is 1000 microfarad. Where does it say that? It says it on there somewhere. On the other side, maybe? There it says. On the left, it says 6.3 volts. On the right, it says 1000 micro F. So it is 1000 microfarad capacitor. And they say why we would want to have it here? They say you want to have it close to the strip between 5 volts and ground is a good idea. And they don't say exactly why it's a good idea, but my understanding is it evens out the power supply fluctuations. Also, it's directional, yeah. So if I plug this in backwards, it's going to blow up. Let's do it. Let's not blow it up, but let's put it in line. So the strip part is the negative, I believe. But let's verify this. I had the little chart that said so. Yeah, it's buried in here. Let me take it out. I had it taped into the inside of this. Here, I'll show you. Turn it around. And then focus. Focus, camera, focus. There we go. Turn. Negative terminal shown by stripe or arrow. See where it says that? There. Negative terminal shown by stripe or arrow. So remember that. That's important. If you plug in these capacitors backwards, they can actually release the magic smoke, if you know what I mean. They actually pop and a whole bunch of smoke comes out. So the white strip is ground. So I'm saying this multiple times so that I don't blow myself up. I'm going to do the ground first, and then the power. There we go. I have a capacitor between power and ground. It's the correct polarity. It didn't blow up. Okay. So let me tilt this so you can see, hopefully see them all light up. Yeah. So they should all light up, but let's not do max brightness at the beginning. Stream is still alive, yeah. Haven't blown anything up yet. I'm super nervous about blowing stuff up, though. Okay, so, let's shorten this a bit. I want the end frame in there as zeros. And I was reading this, there need to be plenty of end frames, actually. There needs to be as many bits as there are LEDs, I think. It says something like that, or something like... So if there are 32 bits in here and I have 144 LEDs, I should just find out where I bookmarked this. Hold on, let me find that bookmark. It's in my private notebook. Yes, right here, I think. They talked about... n over 2 bits. Okay, so I can put this back and then I can then show the notebook. There we go. So this page talks about the chip that I actually have, right? And it says that the end frame, they talk about bits of 0 to work with this chip, which is what I tried and actually was working better, right? But it had to have n over 2 bits of 0, where n is the number of LEDs. So if I have, again, we're doing quick math, 144 LEDs divided by 2. I need 72 bits of 0. How many bytes is that? 9 bytes, right? So I need 9 bytes of zeros to cover the whole strip. I never hit save for that. I'm sorry. Light them up. How many was that again? Oh, did I close it? How stupid am I? Close the calculator. 144 divided by 2 divided by 8. So 9 bytes of zeros. Let me just minimize that. So I have 4 right now. 8. Let's just put 12 in there. So those are our end frames. Now I need to count 144 full white. There's our start. Let's have an off there. Actually, you know what? It's going to get super bright, and I'm going to want to turn it off. So what if I have the off standing by somewhere? Turn the light. It burns. Turn them off. And then we will not... Actually, let's do the... Let's turn them all off to begin with. So delete all these lines. Okay, and then we're going to want would recommend start with 10% or so. Yeah, so just light them at 1. 1 out of 10, 1 out of 31. Let's actually just put them all in line. So FF, FF, FF is white, brightness 1 out of 31. And here, light up. Here I will comment it out to be at the beginning. Which means I don't want that kind of comment, right? I want that kind. All right, so I need 144 of this. So you said do y, and then 143 paste. So that's 100. That's all of them on. Insert end comment. 144 up. 144 down. Okay, so that's 144, all of them on at 1 out of 32. Thank you, Endurin. I should give you a point for that. All right, so then this would be off. Yank, 143 paste. All right. 144 down. Cool. So then these are commented out. Yeah, there's a lot of lights. 144 down. So they're all off if I do this, right? So this is a good test. Okay, it didn't blow up. That's a good thing. And they're off. So let's turn them on. So turning them on would be comment out the off code. Comment in the on code. And here's where the stream dies, right? They're all on and we're still on. We're still live. We're doing it, chat. It's nice and lit up now. Look at that. How lit that is. It's very lit. You can't fool me. We're still going. I don't need those windows anymore. Might need the camera control though. Should I ramp up the brightness now? I didn't do this in a convenient place, did I? I should have had a variable that did this. Yeah, let's turn them off actually. Actually, if I what if I just had the intensity as a variable? So brightness is 0. Yeah, what if I just programmatically do this? 144 DD. And then 143 DD. And yeah, then I can put them all in a line here. This is just that it's white. And the brightness would be E0 or with brightness. Probably get too hot over time. I don't know. The wires aren't hot. That's a good thing. Oh, you guys can't even see the code. I'm sorry. I'm sorry, Endurin. All right. Here's the code where I now have a brightness variable. And I need to take these two lines and duplicate them 143 more times, right? If I put them all in the same line, that would help. What if we have up here RGB? That'd be smart, wouldn't it? Uint 8T red is FF. It was blue, green, red, right? Blue, green, red. Now it's yank 143 paste. 144 down. 144 up. Okay, so this should turn them off at least. Let's see. Okay, turn them off. They are off. Okay, so let's turn them on. So turning them on should just be brightness 1 now. And I'll turn on the hardware so you can see them light up. There we go. Enduran just mentioned no need for new commands, so something like this, just tag me. Should have a function where you get an alert. I was thinking when I work on the stream overlay, I'll let you guys make actual sound effects play, like, wake up! Enduran wants to say something. But be pre-recorded, of course. Alright, should I crank up the brightness? We can go all the way to 31. Let's go from 1 to 2. We'll just ratchet it up slowly. That's brightness 2 out of 31. That's already pretty bright. Should I just YOLO up to 31 out of 31? Am I that? It's probably going to blow up. I don't know. What do you guys think? Should I go for it? It's going to blind me, I think. Do I dare? It should be able to handle it. Everything I know, everything I can think of says it should handle it. Slowly ramp up. But not all the way. Okay, okay. We'll do 3 and 4. So there's 3. Here's 4. It's getting brighter already. I don't think I'm ever going to need to have this run at full brightness. You can see the light shining on me, right? I don't even need this light anymore, probably. Look at that. If that was on both sides of me. So I could probably run at 4 out of 31 brightness. I am lit. The only cable that you're concerned about is the red one between the breadboards. Well, this one is just powering the level shifter. It's not drawing a whole lot of current. The main heavy-duty ones are the ones here that are powering the LEDs directly. Make a loop that increases the brightness. Yeah, but if it blows up, I don't know. Okay, we'll go to the 8. I think that's as high as I want to go today. Oh my goodness, that is bright. Really broke your battery. The light is nice and consistent. What do you think about the light? I think it's very bright. That's only 8 out of 31 brightness. It hurts your eyes standing over there. Okay. Mrs. Raimu says it's very bright and it hurts her eyes to look at it. You literally broke your battery. You pulled a connector off a 9-volt battery? Really? Do I dare go up to 31? She says it's up to me. Okay. How high can we go without... This will be half power. Oh my goodness. This is really bright. And I only really have, like, I don't know, a little bit of... I don't even have it whole strung out. Go big or go home, 100. Do I dare jump all the way to 100? We can go to jump to 24. Okay, it's really bright. Okay, we're gonna do it. We're gonna do it. I'm now encouraged to go full brightness. What's that? Blend it with yellow? But we want to do full power. Okay, here we go. Full power. The stream cuts out, you know why. You'll know why. Oh, it's really bright. It's full power. I can't endure it anymore. It's too bright. It's too bright. Ah, oh, man. My eyes. Okay. The cool thing is that now I can adjust this, right? So I think I'll be okay with 4 for now. What was your favorite color, Enduran? It was it A 0 0 0? Is that right? Nice yellowish color. AA. So this looks to me yellow. It looks yellow to me. It doesn't look orange enough. So the relative brightnesses of the orange, red, and blue, like the hue, is hard to get right because of the different the wavelengths of light. I can point this at the camera so you can see it better. Is that overwhelming the camera? Let's turn it down a bit more. Because you're probably just seeing a really bright white strip. So that looks yellow to me. Lower the AA to 77. So we're reducing the green here. It's still... It's funny, the strip is actually warm over here. The coil. Okay, we'll try A2 EE. That's what you meant, right? It just looks too green to me. I think the green is overpowering the red. What if I reduce... What if we increase the red to full and just drop this in half? So like 66 or something. That might even be too high. Getting there. I think we need even less green. There we go. Now we're starting to look orange. That looks more orange to me. That reminds me of Halloween. What does that look like really bright, though? I should make this a one-liner. Oh, that's nice and bright orange. Look at that. I'm just having too much fun with these LEDs now. So, what do I have for the current task? Line them all up. So now we are testing out different LED lighting hues. How RGB values look. There, I did the colon W as if I was doing VI. Actually, it looks red to me on the camera, but I think that's the white balance is off. How do I fix the white balance on the camera here? I guess I would have to let me hand tune the white balance. Where did that window go? It's down there at the bottom, hidden. Okay, I'm gonna play with the white balance because it doesn't look like... You see red, like almost like a Darth Vader lightsaber red, but it's not, it's orange. I need to adjust, I need to manually adjust the white balance. The other way, maybe? Oh, okay, that's closer to what it's like. That orange. I can't adjust it any more than that, though. It could be. Well, the desk is, what, dark brown? So that's closer to reality. It's probably... Is it because I'm also overpowering it? Reduce it to 4, maybe? I could also play with the brightness and contrast. Contrast? No, that just makes it look more red. It's not red, though. Yeah, it's hard to get the lights to agree. Alright, good night, Endurn. Next project, Running Rainbow. Okay, what does green look like? So now I'm just kind of playing around. I'm done for the day. Nice and green, and then what does blue look like? How did I end up way down there? Blue? Actually, it's only been 3 hours. Maybe I would continue streaming but work more on the Minesweeper game. What do you guys think? Because to go further with this light strip, I need to order more materials. I need to get a board that I can start soldering these components to, right? I have to get the level shifter, this capacitor, and then the power wires into a nice little connector that's easy. Like basically, I can use this connector. This connector also has the power and ground in it. So if I get the other end of this connector and wire it to a board with the capacitor and the level shifter, and then I have a nice nice thing I can attach directly to the ribbon, that would be... Then I would just stash it off to the side and then work on the software parts. It's getting late in the EU, isn't it? And the UK. Unravel the coil. It looks dangerous. It's not dangerous. It gets a little bit warm. Yeah. I mean, I guess I could put it down here so you can see the nice color. There you go. Or tilt it at a slight angle. Let's see if I can get pink. Pink is like a little bit of green and blue mixed in with red. Is that right? I can't remember. I'm just guessing now. Ah, there we go. Hot pink. It's a little bit too bright. One thing I didn't test is, did this light every single LED all the way to the end of the strip? Maybe that's what I should be looking at. Just carefully unwind this. Make sure it lit every single one. And then maybe for a complete test, it would be to actually look at the... this is dangerous. The power wire and the... You know what I'm going to do before I do anything else? I'm going to put tape around the ends of the wire, exposed wires at the other end. I should have done that from the beginning. Let's get some black tape here. Actually, I already had a piece of black tape here in the scissors, so that's good. 2 pieces of black tape. I just want to cover the exposed copper. And let's start with the most dangerous one, the red wire. And I'm just covering up with a piece of black tape the end there, so it doesn't... So, literally doing that. Put a piece of black tape over the end of this exposed wire. And I'll do the same thing with the ground wire over here. Although, the worst that can happen is if I take this ground wire and it touches the power rail. The power rail is on the other side of the desk here. So I just cover it with a piece of tape like that. So now that if they accidentally touch something, it won't be a big deal. And then the end connector, it's got a plastic shield around it, so I'm not too worried about that. All right. So taking it all off of the reel now. All right, so we can see the very end of the strip. There you go. It's lit all the way to the end. So as an off by 1 test, I think what I should do is have the very last LED be a different color. So that means back in our code here, I'm going to take one off the end and just add an extra line here. Actually, we can have the same brightness. But actually, no, let's turn it off. That do what I thought it did? Yeah, so it's turning off the last one. Did it turn the last one off? It did. So, see, the last one is off now, and the one next to it is still on. So that's a good off by 1 test. Let me turn back on. That. And then run it. Oh, I'm in the wrong window. And it turns back on. There we go. Okay. Actually, you know what I could do probably? I could take... They have a connector at the end there. I could probably take that off and use that as the other end of the one connected to the power brick. Hey there, Spheris. Look, I got pink lights now. Look at this. These lights. Light strip. I got it working. And I didn't shock myself or burn any, or release any magic smoke or any of that stuff. Not yet, my son says. Look, I got it all tested, all 144 LEDs. Do you want to see the full brightness test again? It's quite intense. How do I aim this at the camera correctly? There we go. Would you like to see the full brightness test? What am I going to do with the LEDs? They're going to light me instead of having the desk lamp to the side. So I have this desk lamp. See, I turn it on and off. Instead of having that, I'm just going to have 2 strips of LEDs, and then at least it'll give nice, even lighting to both sides of my face. And then software-wise, I'm controlling this through this Raspberry Pi here. If I hook this up to Twitch chat with some awesome software, then you can control the lights. So, yeah. Let me show you the full brightness test. Should we go full bright pink or full bright white? Let's go full bright pink. There we go. Here goes nothing. Oh, it's intense! My goodness, it's really bright. Okay, it looks red on the camera because of the white balance. I don't know if it's possible for me to get a faithful... What if I put it right in the middle? That sort of matches the blinding pink light that's on my face right now. Okay, I can't take the full brightness. Let's go back to level 4. Back to level 4 we go. Yeah, so that's the idea. That's why I got the 144 LED strips. They're a meter long. The idea is to mount them and just turn them to full brightness and see is that sufficient light so I can get rid of the desk lamp and then have nice even camera light. Some knob to adjust the brightness manually. Actually, you know what I want to do is, right now I'm hacking this test program. What I want to do is make a front-end app where I have a slider for the brightness. Should that be what I work on now? I could do that. I'd have to get the program over here. How much work would it be to do this? I'd want to set up some service running on the Pi that I can connect to with the WebSocket and just feed it. Basically, I just wanted to feed it the these values for every LED, what the brightness is and what the RGB values are. Make it a sine wave. Yeah, I mean, we can... The SPI runs at, what, 500 hertz at least? So it only takes like a fraction of a second to update the strip, so we can actually even animate the lights. I could have a light that goes from one side to the other. I could have it do a rainbow. I could do a sine wave. Yeah, I can do all that stuff. I could actually let you guys do it through Twitch chat. That's I think, going to be the stretch goal here. Is not only do I have the lights, but maybe in exchange for channel points, you can briefly control the lights yourself. Kind of like what Adam had for a while. I kind of like the pink glow around the setup here. You can see what was on the proto board. The most dangerous thing is over here. All the current that is being chewed up by the light there and being converted some of it to heat is running through these two wires. And they are, I'm not going to scrimp on that. I'm not going to use 28 gauge wire. I'm going to stick with 20 gauge wire. And if I have to order more parts, I will. Haven't reviewed your PR? Oh, you updated it, right? Yeah. I need to do that. Definitely. And thank you, Aiden Garth. I know you worked on that a few hours, like 8 hours ago. So thank you again. So I'm trying to decide, take a break and work back on Minesweeper again, or do more with these nifty LED strips? I don't think I'm going to do anything more with the hardware, but with the software I could do some work. I would, I'd make a program that I run on the Pi that just listens to, actually doesn't even need to listen. It could just be a web server that I would put a document in. We could just make a JSON or something, and then it just shifts it out to the yeah. What if I do that? The light is actually annoying to me a little bit, so let me turn it off. And turn off the hardware. You're gonna make it completely TypeScript? Or your PRS based? Yeah, I was hoping that the I could ease slowly into TypeScript by just enabling some of the features TypeScript gives you, but not have to switch to TypeScript. That was what I was hoping to do. The battery officially dead. Take another one from the smoke alarm. You need that smoke alarm though. Yeah, you don't want to disassemble batteries. So the one you pulled the terminal out of, I would just safely dispose of that. All right, I think I'm going to switch to this is bonus time. I'm going to at least make the web server, and then we can manually control it a little bit through, well, I guess I should make a front-end app to do it too. All right. So that means I'm done with this program, right? I'll want to get access to this code. Well, let's keep this window up, but I don't need this shell anymore. And so the current task is going to switch a bit. Moo? 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 Moo. Current task. Just looking at something. The tape from one of my leads is coming off. Huh. Oh, black electrical tape is a good idea, even if I didn't pin it down well enough. All right, so these wires are not hot, are they? No? So I did okay with the soldering today, even though I struggled with it at first. Okay, so making a little web server to run on the operate the LED strip on the Raspberry Pi. And I'm going to turn on the overhead light. Now they don't have a light strip. What about someone emails you a new battery? Can you send batteries through the email? Have them send you more RAM at the same time, right? Okay, I'm going to make a new program. So we're talking new directory and everything. Let's make a directory lighter. Lighter. Get init. Copy from here my editor config and the git ignore and the cmake lists and the main.xml. Did I say moo at some point? What's this moo clip? Let me watch it. That's just me saying moo. Okay. I'm like, what the heck? All right. So open folder. Lighter. Open. This is totally going to freak out because there's a CMake list and no actual code, but we can pick. For us, it's going to be this one, right? Yes. It's going to freak out because there's no code, but that's okay. I'm actually surprised it's getting so far. Okay, there it crashed. Okay, so then what do I need from repositories? I don't need that one. Don't need AWS. Probably need that. I probably don't need. Well, I might need crypto signing. Leave it in there for now. Don't need Discord. No. No, I want to just control this locally at first. Discord play hash. I probably need. I definitely need HTTP stuff. Okay, don't need that. I do need JSON. I need LibreSSL. I need message headers. I don't need that. Any of this. I probably need the clock. Packaging, I might need that. I'm not sure. RAF don't need. I don't need the SASL or SMTP auth or serialization. String extensions, yes. System abstractions, yes. Timekeeping, yes. TLS Decker, yes. Don't need Twitch yet. So I'm going to remove it for now. URI, UTF, yes. We want to control through WebSocket? I don't think I need to. Yeah, I'll just leave it out. Web token, no. I don't need the AWS test suite. Sure. Am I going to write unit tests for this dang thing? It's a little one-off project. Yeah, let's not do tests yet. I'm going to regret this, but... Oh, no, let's leave the tests in there. I can choose not to run them, though. Can you send steak through the emails? You need food. Nope, sorry. Issues, no. Lua, no. Zlib, yes. Okay, I think I got the repositories I want. So then, let me clean out the git ignore. It just has that in it. And then, editor config is fine. I think we're good. Let me update the CMake list. This is for, lighter. And it's this year. This is not proprietary. I'll just open source this, why not, right? And static linkage, dynamic linkage, Google test, RPath stuff. Don't need the AWS test suite. Need LibreSSL. Why does it say plain text? This is CMake. This doesn't know CMake. Why not? Weird. Anyway, we don't need Lua. Okay, what did I remove again? I guess I can just compare here. Base 64 is the first one, then crypto signing, then hash, then HTTP down to... I don't need that. JSON message headers, remove these. After message headers was the clock. Packaging is next. I don't have packaging in here? Oh, that doesn't actually build anything. It's just got packaging scripts. I probably don't need that then. So the next one will be string extensions. Then system abstractions. Timekeeping, TLS decorator. URI is after TLS decorator. UTF-8 don't need the WebSockets web token. That's it, right? Google test zlib. Zlib is included up here. Okay. So then we're going to have one thing called the lighter. All right, and then I need to make a directory called lighter. And then I need to add a CMake list in there. And this needs to just be a simple program. So let's leave it blank for now. Let me mugget select main, mugget pull. Pull all the repositories from GitHub. See ya, Manes. Thanks for stopping by. Thanks for being here and watching all that stuff. At least some tests for limits. Yeah. Okay. This project is going to drive this LED strip. It's called Lighter. It's just a little side project. I really just need to be able to minimally turn the lights on and off. So what I'm going to do is make a quick little web server that I can connect to from a quick little web front-end app and have a slider to turn the lights on. So I should be able to do this hopefully in the next hour based off of the other components I've already made, right? So this should configure but not actually build any app yet. Unless I missed something, we'll find out. An error occurred. What am I missing? Mini zip is needed by what? Which CMake list is that? Oh, I needed a special... Hold on. I think this is a bug in Mugget. I have to do select again and it pulls the correct branch of zlib. Yeah, I never went back and fixed that. After you select main and then pull, you have to select main again to get the correct branches. I always forget to do that. Okay, so it actually built, or configured, so now let's build. It should just build all the libraries with no apps yet. I think what I'm going to do is steal from the original Excalibur project the test web server that I had. Actually, that's probably a bad idea. A better idea would be to steal from the WebGate code from the game. Alright, so it built successfully. So, let me find the test program I had. Where's a test program that would be suitable? Do I have one under HTTP? Test? No, that's unit tests. I can't remember if I had any test programs. Okay, we'll just open another window. Go to the game. And let me locate, I don't know, how about Newman? Where was our old friend Newman? The test email program. Okay, so, sure, we'll copy the README, because I forgot to do that. Copy the README and paste it in Lighter. And then copy the contents of the CMake into here. Alright, let's update the README. Lighter. This is a standalone program which runs an HTTP server. I don't even really need to worry about security yet, right? I can just drop all the TLS stuff for now and just go straight simple HTTP. This is a standalone program which runs an HTTP server, allowing clients to control an LED strip. All right, so it's just going to be Lighter. I don't think I even need any configuration. Make a license too? Yeah, probably a good idea. Hey there, Aiden Garth, thank you very much. Let's pull the MIT license out. There we go, and update the copyright year. Although, I'm starting to think I don't need a copyright. So, usage Lighter. Run the HTTP server until... was it sig int? Control C is until sig int is signaled. Only pressed. That's what we want to do. All right. He started the rerun. What's the rerun? Oh, he's running an old stream, a rerun of a stream. That's interesting. I don't think I've ever seen him run a rerun. Okay, it's a portable program which depends on the compiler, libraries, and other library. Yeah, exactly. So that's why I picked the Newman README, because it's already in pretty good shape. This one is bad though. Do I don't want that. I need a better test program that had this language in it. Was it Port Squatter? I didn't even bother to make a README for that. There's got to be something I made a README for recently. That's got a good... let's just search for README. Why? Oh. Oh, what am I doing? I don't want to search for the string README. I want to search here. Is there a way I can do this? README? .md. Oops. Let's try again. readme.md. How do I go to the next one? I don't know how to work this one. Is it in here? Aha, filter. Did I really not have any other readmes other than Newman? This must be wrong. There must be another readme. Like, for example, Raft has got a readme. Okay, so that search thing, I don't know how to operate it. Let me go from the top. Maybe AWS Play. It doesn't even have a readme. Okay, never mind. Discord Play has a readme. Aha, this is what I want. I want this language here. It's a portable C++ application which depends on the compiler standard libraries. Okay, that's exactly what I want. And then, oh, wait a second. That was this section up here, wasn't it? Which is already okay. So it's this one. Not intended to stand alone? No, this application may stand alone or be included in a larger project, which uses CMake. I misspelled project. Which uses CMake to generate the build system. There we go. All right. So prerequisites. I'm not going to bother with this yet. Definitely don't need those. Actually, can I pull the prerequisites from? No, I'll do this later. How do I mark a to do here? To do. doesn't like that. No emphasis for a mark. Okay, what if we just do to do? Need to list actual prerequisites here. All right. Okay, that's good enough. Okay, read me. I mean, CMake list. This is not Newman, it's lighter. It just has a main, so let's make a main. Main.cpp. Done. And we're pulling in hash, so yeah, don't need the SASL SNTP thing. Don't need the TLS decker even. I know I need the HTTP and HTTP network transport. Do I need that directly? I don't think I do. I don't even think I need hash directly. Hey there, Ramy. Were you here for see my LED light strip, Ramy? See me light it up? Brightness 1. I don't want to overpower my... Actually, we can do 4. Oh, I closed the other window. Shoot. Let's open it again. I shouldn't have closed it, because if people want to come in and see me demo it, so that's Project Spy, right? And sudo spy test dev spy there. And I have to build it. GCC output spy dev test spy dev test.c. Look, it's pink. Look at that. Let's turn it off. So I have the LED controls working for this hacked up test program. So what I'm working on right now is building a little web server that'll have that code in it now. And then run that on the Raspberry Pi and connect to it from my main computer, and then have like a little front end app that I can turn the stuff on and off. What speed do the LEDs operate at? This actually prints it out when it starts. 500 kilohertz is the bus speed right now, so it's really, really fast to update. I mean, that's the speed of the data bus into the LEDs to change their state. How fast they operate in terms of how much, what's the period of the PWM pulse? That might be in the data sheet, but I don't remember. That would list it here somewhere, right? Frequency of the PWM, 1.2 kilohertz. There you go. So it should be flicker free because it's high enough PWM frequency. This other number, the 500 kilohertz, that's how fast we clock in the data. So we have to clock in 144 times 32 plus some overhead, let's say 96 bits. Or, yeah. About 5,000 bits at 500 kilohertz. So it should... How much is that? 5,000 bits divided by 50,000, right? 500,000. So about 10 milliseconds is the rate at which we can change the LEDs. So 1 over that would be what? Where's the 1 over button? Here it is. So we can get 100 hertz refresh rate on the LEDs, roughly, if we ran it at this bus speed. I'm guessing we can go even higher, though. I've read that you can go into the megahertz with this LED strip, and it's just fine. 100 hertz is refresh rate for this LED strip is fine, because if you're just keeping it on, you don't need to update it at all. It just sits there. I can even disconnect the data and clock, and it'll stay lit. Because each LED has a little microcontroller in it that sustains the output. All right, I'm making a little web server now. Thank you for the follow and all the other follows. I didn't really do many waves today because I had my hands on trying not to blow up my desk with this high power. It's running upwards of 10 amps to light this strip if we had it on full brightness. And so I didn't really get a lot of opportunity to interact with chat directly in Wave, but you guys are cool with that, I hope. I'm going to put that down there. Okay. I'm going to make a little program here. So let's cheat and start with another program. Let's take Newman and just paste it here and say it's an entry point for a new program. And I probably don't need all this stuff. I need the diagnostic reporter. I need the network connection, and I need signal and all this stuff. I don't need the TLS decorator though, but I do need the web server. Server. Yes. Okay, and I need the network transport. HTTP network transport, server network transport. So let's clean out this stuff. I don't need any of this stuff. Well, hold on. There might be some useful bits in here. I don't think I need any. The usage information would be nice. Usage, lighter. Let's copy from the README. Run an HTTP server until Control-C is pressed. And there's no other configuration. Alright, there's a shutdown flag. There's an environment. We don't need anything from it yet. Maybe in the future, so we'll keep it here just in case. There's the interrupt handler, which is SIGINT, so we'll set a shutdown flag, which we defined up there. Here's the process command line arguments. We don't have any, so I'm just going to do nothing here. It's all going to be extra arguments. Lighter, extra arguments given is an error, I guess. And we don't have any required arguments. It's mostly just a shell here. I don't have a login function. I don't need to set up a client. I don't have an email that we need to read. I don't need this, or await future, or connect to server. I don't need any of that. All right. Here's the main program. Okay, technically that, don't I need an include if-def win32 thing? If-def win32. Yeah, this thing. No, not that one. I need the one that's around the pound include for it. This one, CRT debug. I always forget to add that, but we really should have that there. Because that's used for this to check for memory leaks. And it's just nice to have boilerplate. Okay, so set up our interrupt handler. Set up an environment, don't buffer standard output, set up a diagnostic system, parse our command line arguments. If we get this far, we're going to do our thing. And I think that's all we need. Oh, we should have a loop, right? I should have like a while. Let's look for where I might have done a while not shutdown. Yeah, here we go. Did I? Okay. Did I call it shutdown? Yeah, I called it shutdown. One of these where we just do a sleep. Why do I have long? Yeah, one of these is fine. So that's all I really need here. We'll include the K thanks bye too, because that's nice to say, right? Alright, so then, and then that's this, there, this is shut down. Okay, for that I need to include thread. Have a good one, Spheres. Thanks for being here. Okay, so this is a program that'll do basically nothing until I hit Control-C, but it's basically the shell for a program, and I'm missing, okay, this needs to be in a directory called source. Move it in there, yes. And then build again. Cool, so now I should be able to run it, right? CD lighter, build, VS Code, lighter, where did I put it? Lighter, and then Control-C to quit it. K thanks bye. Okay, good. So then to actually make it run a web server, what do I need? Let's steal from the web gate from my game. So web gate. Let's make this window bigger, but not cover the other one entirely. Almost though. Okay, how does this get set up? It's like bind something, right? Bind. Try bind. Right, so we set up some dependencies, some configuration, and then we just tell it to register a resource, right? Okay. And then mobilize. So let's put this into a function called start web server. Void or bool start web server. Okay. And then let's have the resource thing something we pass in, maybe? Oh no, let's we can do the register resource later, right? I think so. So I can take this one out and put it in another thing. Void well, hold on. What does that actually do in it? What kind of resource do I want to have? Like, just let's have a test. Register test resource. Okay, and then so we need a timekeeper. Timekeeper, I have one in main. Here, timekeeper, right? Right here. Should I just copy this as is? Does this work with the web though? I can't remember. We don't need this readme anymore. Is current task correct? Yes, it's correct still. All right. WebGate. Oh, we need this too. Attach the transport layer. Okay, so what do we do with the WebGate? Subscribers diagnostics, attach it, yes, and then... Okay, is it the coordinator that connects the timer to it? Coordinator impl mobilize. Actually, that would be coordinator.cpp mobilize. WebGate. I'm trying to see where do I set the timekeeper. I forget where I did that. I guess I really don't need to look for it. Maybe it was in main after all. I don't know. Could be. Let's pin that. Let's look for WebGate again. What languages do I know? C, C++, C#? Yeah, I know all those. I also know JavaScript and Python. Although not, and whenever I switch to Python, I'm always very rusty. Lua. I use Lua for the scripts in my game. I used to know Perl, but I can't claim that I know it anymore since I haven't used it in years. And if you consider HTML and CSS as languages, I know a fair amount of that. So there you go. My bot says what I know. Whenever you switch to Rust, are you very Python-y? Well, I haven't actually learned Rust yet. So we'll have to see. Okay, here's the timekeeper. What kind of timekeeper do I need? Okay, yeah, it just needs to be an HTTP timekeeper. Okay, so it already is. So what if I just steal these and put them here? And then include here that we're going to pull in source timekeeper CPP and source timekeeper.http. And this uses the 09K clock. So that's a dependency. 09K clock. Let's build that. Oh, there's other things that it says we don't need. We don't need that. Right, so it's only needs to be a clock for HTTP, and I actually technically don't need that right now. It's okay to leave that in there. So if I do leave that in there, I should probably make it dependent on timekeeping. You said whenever you switch to Python, you're very rusty. Oh, I get it, Phil Powers. I'll give you a point for that. All right, yeah, all the copy-pasted code won't build. That's okay. So there's no realm server timekeeper. This one should be fairly... Yeah, it's just get the time from the 09K clock. Okay, so then we'll work on this a little bit more. So the timekeeper, I think we can just make one here. So this is a shared pointer, so I can say standard make shared timekeeper. And I can just include our timekeeper. Do I do system includes first? I can remember this stuff. I think I do system includes last. Timekeeper.http. And then I need a transport layer. So that I remember seeing a little bit back here. This stuff here. So I don't need to worry about TLS, right? I just need one of these. Where is this thing? Right, I need to make an HTTP network transport layer. And I just need to make one, right? Yeah, so I can just do that here. Auto transport is make one of these, and then subscribe to, okay, I want to actually, I want to pass in the whole message. Do I want to do the delegate like that? I don't think I want to do it this way. I want the whole sender. Diagnostic message sender. Let me fix this up. Hey there, Smur. How are you doing? Diagnostic message sender dot send string. And then I don't need this in front. Right, and then if I, and that could be const because I allowed this to be used on a const one. So yeah, so then I can put that here and then say, subscribe to that dot chain. And I'll just hard code the level for it now. And then we get the transport and we set it there. Okay, and then I need to set the port number, right? So what port number should we set? 8080? Why not? It's going to be a local port anyway. And I don't need this stuff, do I? What else do I don't need any of this junk. Okay, so that part should build at least. Okay, didn't like this one. Why not? HTTP undeclared. Oh, we need to actually have a server. So, let's make one. HTTP server HTTP. And that can then be a dot, not an arrow. And I need to, let's actually call this from the main program. So, it says squatting successful? It shouldn't say that. So, web server active. Okay, so right here we would make one. Start the web server. So, if we couldn't start it, let's define it out here. Here's our web server, right? Then let's try to start it. And then our sender is diagnostics publisher. Right? Actually, what does this return? It returns a delegate. I need a sender. Okay, so let's make one then. System abstractions diagnostic. Okay, I need to include the right header for that. Diagnostic sender. Diagnostics. Why is it not giving me the IntelliSense? Probably because I didn't have 2 colons there. There we go. So diagnostics sender. And then I have to tell it that it's what its name is. It's lighter. Okay, so then the publisher should subscribe to it then. Sender.subscribe publisher. This one. Okay, and then I can use the sender down here. And then we will fprintf to... I use fprintf when there's a problem, right? Yes. So fprintf to standard error. Unable to set up... We want to say error in front? Error. Unable to set up web server. and then return exit failure. All right. And that goes there. Now what did I miss? What's it trying to tell me? Probably because I have some errors up here. Can't set a configuration item. Cannot go from... Oh, that needs to be a string. And I can't return... So basically I just want to return the result of mobilizing it. Okay, and then we're going down to here. Registering a resource. So there's no server, so we need to have a server here. And it's going to be a dot. And the test resource is going to do what? Let's just... let me think about this. Yeah, we don't need any context, right? We're just going to have it respond 200 saying hello world or something. So, right, the response dot status code is 200 response dot headers. Oh, I already have it down here. Do we want to set the reason phrase? I guess that would be the polite thing to do. Response.reason phrase is okay. And then it's text plain and the body is PogChamp. And then that's all I need, right? Then just return the response. Alright, and then we're getting down to the, what is this error? Cannot convert from a message delegate to a sender. Oh, right, because we want the sender, not the delegate. So that goes there. Cannot link with timekeeping. I thought I included that. Oh, it's lowercase. Interesting. So I didn't think it would be case sensitive. But okay, good catch, I guess. Thank you, compiler. So I want to go to here and say timekeeping. There we go. So this should run a web server. And it pops up a thing saying, are you sure you want to let it talk to the network? Yeah, I just wrote it, so let me talk to it. So now while it's running, I should be able to talk to it. Local host 8080. Why does it say feels bad, man? Shouldn't it say, PogChamp? What did I get wrong? Feels bad, man. I think that's the default 404. I guess I can look in the debug to see why. I want network. Let's put it there and reload. Yeah, I got a 404. It means it didn't register the resource. Oh, I forgot to call a register resource thing. I'm just stupid today. I need to call register test resource. Register test resource HDV. There we go. Can't run or write to it because I'm running it. So Control C, then build it again. All right, and then run it again. Then refresh. PogChamp. So I got a web server running in about half an hour. Now I need the web server to actually control the lights. Actually, no, it'd be good to just push this and then build it on the Raspberry Pi and make sure it builds there, right? Let me strip out stuff I know I didn't need. Oh, I also need to assemble the yeah, I messed up here. I actually put them in here when I shouldn't have. Well, no, I did that to clone them. But they're not in the git ignore, right? So if I do a git status, it's going to say that all those things are... Yeah, so I can... I guess I can just manually add them. So add these to the git ignore list. Git ignore paste. Yeah, that'll work. Go up, wrong way. Go down, and then unindent. Okay, and then not that one. And then I want to put a leading slash in front of that, right? And make sure these are all sub-repositories that are to be ignored. I think that's right, except for lighter. Okay, so then git status. Editor config, git ignore, cmake list, slider, main, yeah. Oh, zlib is missing. Zlib. Okay, so now what in here did I not need? Let me follow the dependency chain. Maybe this is a good opportunity to set up the README dependency list also while I'm at it. So, where am I? I'm in timekeeping. I don't want to be here. I want to be in, let's collapse it all, go to lighter, README. Okay, so then I have a to-do list, right? So let's look at my dependencies. HTTP, so rather than type it out, I'm just going to search for the word HTTP, where I've already written this out. Look at that. So grab that and paste it there. And then what's next? HTTP network transport. There it is. And then while we're at it, we'll grab string extensions and system abstractions and paste them here. What else? 09K clock. Do you know why it's called 09K clock? Because it's over 9,000. I was just feeling whimsical that day. All it really is a, I don't even have a reference to it. It's just a clock generator that uses the high precision. It uses a melding of the high precision timer with the real-time clock. Hey there, Phantasmics. Work's been chaotic lately. Hey, look what I got working today, Phantasmics. Check it out. I'm gonna light them up. Are you ready? Gonna light it up. It's pink, and it's very bright. It's actually only 4 out of 32 brightness. So the first 3 hours of my stream was wiring up this LED strip. The last couple hours is going to be controlling it through a web server. Yeah. Hey there, Ski Dog. Using the Ski Dog camera. Hi. Ski Dog graciously let me have this camera so that it's much improved now. We can look at the work. Do you want to see full brightness, Ski Dog? I'll do it once for you. We'll do the brightness up to 31, and we'll do all the LEDs are on, so it's full bright white. You ready for blinding bright white? There we go. Full brightness. That is super, super bright. I did turn it off now. I can barely even see my own screen. It's so bright. The most scary thing for me was setting up the power connections here, because this draws upwards of, on paper it said it would be 2.8 amps, but when I was measuring it, each LED was taking as much as 40 milliamps, and my quick math said that at 40 milliamps times 144 LEDs, that would be actually 5.76 amps. So yeah, it's kind of scary. I even put the little capacitor in there to make the power line stable. Turn off the lights and then light the LED strip. Yeah, so it's 144 LEDs. It's a meter long. I can control every individual LED, so they're all individually addressable. And I just dropped a bunch of frames. So that wasn't you, that was me. My uplink to Twitch died a little bit there, but it looks like it's back to normal. But anyway, what I was saying, if I got cut off and you didn't hear me, it's a meter long LED strip, 144 of them, and they're each individually addressable. The brightness can be set from anywhere from 0 to 31 per LED, in addition to the RGB values, which means you can also dial down the brightness by dialing down the color values for each LED. And it's driven by through a SPI or SPI bus from the Raspberry Pi here. Goes through this level shifter, which goes from 3.3 volts to 5 volts, which is what the LED strip wants. And then because it's drawing upwards of anywhere from 2 to 5 amps of current at 5 volts, we have this independently powered, on this power rail here is, I soldered this together. This is going from one of these, what do you call them, barrel jack connectors. I cut the end off, took the wires and soldered posts to them to stick into the proto board, and now I have a 5 volt power rail, which is very scary, but works. And the next step for the hardware will be to fit all this into a little proto board soldered together with an actual connector at the end that will probably be this connector, and then that would you'd plug in the it would have a barrel jack also. So you plug in this connector for data and this barrel jack for power, and then I just have to Raspberry Pi it over to the side hooked into the other end of the barrel of the data connection. So that's the eventual goal, but today was just prototyping and getting it to work. And because we got it to work so successfully, I thought, let's take the next step and have, instead of hacking this test program to set the brightness and the colors, let's do it in a little web server. Yeah, it is pretty awesome and awesomely bright too. And yeah, I got a little bit caught up in the weeds here, figuring out what the dependencies are for the web server. But I made a little web server. It said PogChamp. The code for it is right... Where is it? I'm lost now. I'm in the wrong window, that's why. This window. It says PogChamp. So this is my web server. This is what a resource in code looks like for my web server. So my web server, you have to give it something that tracks time, something to make network connections. You have to configure the port number it's on, but then that's it. You just tell it to mobilize, and then when you do register resource, in here you can specify the path, the URL, the path part of the URL, but basically we're saying everything in the path. Run this, and we just construct a 200 OK with PogChamp. So what I want to do next is, once I want to get this running on the Raspberry Pi, and then I want to change this so that instead of just saying PogChamp, I want it to like maybe tell us what is the current LED light setting. And then I want to have another resource, probably a put instead of a get. Actually, where do I set? I think it's defaulted to get. Oh, that's interesting. Where do I set whether it's... Oh, right. It handles any kind of method. The request actually tells us the method. Request.method. So this would work with a get or a put. So yeah, in addition, in response, we would have to look at the request method to see if it's a put, then look at the body of the message or whatever. I guess not the body. No, for a put, you look at the body, right? So I'll probably make the body a JSON, which is the data to put into the LED controls. So once I get the data, the way this works on the Raspberry Pi is you just assemble a huge buffer with there's 4 bytes for every LED, so there's going to be 144 lines here. You put that into a whole huge buffer, and then you use the SPI IOC transfer structure defined in Linux, and then you run this IOCTL or IO control system call, and that just tells the hardware to send that string of bits through this SPI interface, which is a serial bus interface. Really, really simple kind of bus. It looks like this. There's a clock, and there is data. And literally 1 byte from this program here gets sent out 1 bit at a time on the SDI line, and with the clock alternating along with it. And then that interfaces to the LED to capture the data into this kind of format, which tells the LED how to light. Top 3 bits have to be 1. This, where it says global, that's actually the brightness, and then the blue, green, and red values. And then you just put a proper framing so you know, so that the LED string can tell a difference between whether you're still shifting something in or whether you're starting over again, or if you're at the end. You can do LF line endings too. It's \n instead of character turn line feed. Not with HTTP. With HTTP, you're required to have character turn line feed. I remember looking at that. Because HTTP is a very old protocol, so they actually say somewhere you're supposed to have that. I mean, I could probably get away with doing that, but we're gonna be. I'm old, so we'll be old school. How about that? So yeah, I was going to collect the dependencies for this little dinky web server, trim it down to just the essentials I need, build it on the Raspberry Pi, and make sure I can talk to it the same way I'm talking right now to localhost PogChamp on localhost 8080. I want to go to buddy.local 8080. So right now, there's nothing there, right? It's a failed. We don't want it to be failed. We want it to actually work. If a child refuses to sleep during nap time, are they resisting arrest? Mr. Balrog, you deserve a point. How come you only have 2 points? Didn't I give you more points at some point? At some point? All right, let me trim off the dependencies here. I had 09K clock, which I couldn't find a reference to. So how come I couldn't find a reference to that? 09K clock, do I not have a reference to that? Oh, I do. I guess, no, that's in the README for it. Interesting. So I never actually listed it as a dependency anywhere. All right, well, let's just do it live then. I guess we want to list it up here first. 09K clock. And then a reference to it. This is 09K clock. And the README said that a library, we'll just say that. A library which implements a high-precision real-time clock by combining separate real-time and high-precision clocks provided by the operating system. Period. Do points persist to the account? Yeah. So points actually go into my game's web server. Okay, before I do this, let me turn off the F12 screen. Yeah, because I don't want to leak any credentials. So, the bot is actually coded into my game server, which runs in AWS. And so, for example, we can see that Mr. Balrog... Oh, Mr. Balrog doesn't have a player account, so we won't see it. But if we look at someone who does, like Ski Dog, for example, really don't have any points? How come Ski Dog doesn't have any points? Oh, because you're not associated with Twitch, right? Someone who's logged in through Twitch. Let's just look at last logins. Recent logins. Like Domson, 24 points, right? So if I say points, Domson, bot will say 24 points. You had an account at one point, did you delete it then? And it doesn't pop up. So maybe you deleted the account at one point. Yeah. So they're persisted in the game, actually. Every time I give someone a point, the game actually records it. Oh, look, there's Domson. You never deleted the account? Did you name it something else then? Or are we losing accounts? I was waiting to change your username. Always had the same name, really? Oh, I wonder why it's not showing up then. Huh. I don't know. There I am. There's Rock'em Sock'em Raimus. I don't even know who that is. Yeah, anyway. That's that. You're one of the first to link with Twitch, so I don't know what happened then. You saying you didn't delete your account? I guess I can go look back through old backups and see what happened. Weird. I'll have to restore your account then, if it got damaged. Okay, I got 09K clock. Yeah, yours isn't linked to Twitch, but you do have points associated with your account. Oh, no, you don't? I need to give you some points. Let's give you 5 points. There. Now you have 5 points. You're not useless. You gave me this awesome camera. Look at this. And the camera deserves 5 points, doesn't it? Easy points, yeah. All right. I need to list all my dependencies here. What are the other two dependencies? System abstractions and timekeeping. Okay, so I'm missing the timekeeping one. I probably have that over here somewhere. Timekeeping. I do, look at that. Okay, so I've done the right thing and listed all my dependencies. So I'm going to look at the dependencies of the dependencies. So HTTP first. That depends on message headers, time taking, zlib, URI. So we need all of those. And then, oh, you linked your account. Cool. Nice. It starts with a T, ends with a T, and it's full of T. A t-shirt? I don't know. I guess I should do a depth first search, so I really need to write a tool for this. A teapot full of... I get it. Okay, you get 1 point for that. String extensions. Okay, so then string extensions, system abstractions. I don't think system abstractions depends on anything. Yeah, it doesn't... Oh, it depends on string extensions. Fine. All right. Timekeeping. What does that depend on? Nothing. URI probably doesn't depend on anything either. String extensions, fine. And then, so zlib is standalone. So then, that's it, right? So I don't even need UTF-8? Really? Let's actually search for that in make lists.txt files. And let's ignore libra /SSL/**. Oh, okay. JSON needs UTF-8. I'm going to use JSON eventually, but I don't need it now, so I'm keeping it in there. All right, then I don't actually think I need the TLS decorator. I'm going to delete that. Remove RF TLS decorator. Because this is just going to connect locally to my stream helper or to my web browser. So then I'm going to drop it from here. And then they get ignored too. Okay, what else? I didn't need base 64? I guess not. Okay, base 64 is going. Let's remove these unnecessary dependencies. Remove RF base 64. And then crypto signing. We didn't need that one. Nope. I don't even know why I brought that in. It's just a simple lighter. We don't need a crypto signing. And then what about hash functions? No, I don't need hash functions. Weird that I don't need hash functions though. I thought almost everything used them, but I guess my web server doesn't need it. Okay. I actually don't need LibreSSL if we're not doing SSL, right? Yeah. That's a big dependency I don't need to build on the Raspberry Pi. I'm trying to slim this down because this is going to run on the Raspberry Pi. Hopefully everything builds. If something doesn't build, I'll be sad. I don't think I actually... Do I need... No, I needed zlib for... The web server needs zlib. That's right. Yeah. I'm not going to have SSL to the Raspberry Pi. I'm not going to open it up to the internet directly. What I'm going to do probably is if I let chat control it through Twitch chat, the stream helper will turn the command into a local request to the Pi to change the lights. Yeah. The link between Twitch and the lights is going to be 2 steps. First, it'll reach my stream helper, which right now is just doing background moderation tasks. And that will then make a local request to the Raspberry Pi. Don't need SSL or any of that to if we do any command that changes the lights. All right, so let me make sure this actually builds. Why is F7 not working? Let me reload this. I have no idea why F7 doesn't work. Configuring. Why is it having a hard time? Maybe I should just wipe the build folder out. Let's close this one, and let's just wipe out the build folder. Probably need to get out of this. Oh, because we're running it. Okay, so get out of there. Wipe the build folder. It's busy. Why? I want it gone. My system, like, almost... That was scary. OBS is having trouble. Great. We back? My OBS? No, there's like a delay. Shoot, did that screw up the stream? I'm seeing a little bit of delay on it. Why can't you see their chat and Omnia? Probably because they're doing the in-game chat. Okay, yeah. VS Code went into some kind of tight loop that almost crashed my system there. I've only had that happen like twice ever. Because they're hackers. I dropped some serious frames, but I'm still here. Yeah, it caused a bunch of frame dropping, no big deal. Oh yeah, you're talking about the chat from Twitch. Yeah, the chat from Twitch is relayed in-game right now. That was an effort to reward VIPs and up that their chat is visible in the game, because the game is meant to be like highly integrated. Okay, something needed TLS decorator. Right, this one. These shouldn't list the things I don't need. There we go. Okay, now what? Lighter says it needs it, but it doesn't, so we'll drop it. Did I actually list LibreSSL here? No. Where did I list it then? Hold on, what? Line 86. Of what? Oh, of the main one. I think I know where that is. Let's find it again. Yeah, it's listed up here, right? So drop it from here. There we go. Is it possible to chat with other players? Yeah. There's an in-game chat command. You have to be unmasked, though. So it's possible your account is still masked. Okay, Aiden Garth was masked, so now you're not. So you should be able to do this chat command. Hello! And then the GM says hello. If other players were to chat, it would show up here. Anybody gonna help me test it? How long is the delay right now? Last time this happened where my system froze up, it turned into a 5-second chat lag. Oh, there we go. Om says hello! Dumpson says hello! Can you hear me? Yes, we can hear you. About 3 seconds. Oh well. I'm probably not going to be streaming that much longer. I just want to get the web server up and have it just turn the lights on and off would be nice. Through a get. I guess we'll keep it as a get request for now. I won't even do the front end app. All right. So it didn't build. Why not? TLS is not found. Oh, line 33. Right here, right? Oh, right. This custom TLS thing. We don't need that. Build. Okay, I'm gonna build it, run it, make sure it runs locally again, and then check it in, pull it over to the Raspberry Pi. Now that I think about it, do I have my key over there? No, I do, because I pulled code. Yeah, I think I did. Yeah, I think I did, yeah. Okay, so it works. Let me check it in. All right, new project as an editor config, a git config, a git ignore, a make list. It's got stuff for lighter in there. Shouldn't those be at the root? Actually, no, they could be. There should be a copy of the license at the root, though. And there should be a copy of the README at the root. And we're gonna say that this is a workspace for building lighter, a standalone program. So let's just remove the usage in building. Right. This works. This is okay. This is a stand-alone workspace which uses CMake to generate the build system, provide the application with its dependencies. Exactly. And it doesn't actually have any direct dependencies other than the tool chain and the other things it pulls in indirectly. I'm just going to list that. There we go. And then the overall read license is the same. So if I want lighter to stand alone, it should be its own sub-repository then, right? Well, no, let's leave it the same. I'll figure this out later. I'll just check this in. Initial revision. Okay, and then I need to go on to GitHub really quick, and so we'll make a new window. Actually, hold on. What happened to my stream view? It's still there. Okay, I'll use that one. Go to GitHub. Make a lighter. Repository name lighter. And create repository. Okay. Yeah, now that I think about it, I don't know if I have now that I think about it, I don't know if I have the Git set up the way I want, but that's okay. Hey there, Tim. Yes, indeed. Look at this LED light strip. Check out the hacked test program I have to turn it on. I'm even using VI to do this. Let's make it brightness 4. Build. Look at that. Brightness 4. And it's white. Look at the light. It's very nice. I'm not going to do full brightness because I almost blinded myself twice. They are very bright. There are 144 LEDs, a meter long, and it takes somewhere between 2 and 5 amps of current to run. So I had the test this test program up here. It's running on the Raspberry Pi here, going through this level shifter to go from 3.3 volts to 5 volts. And then the data and clock right here, the green and yellow lines, go into the LED strip. And the power and ground come through separately through a 10 amp power brick on the top here. Goes with this capacitor to keep the voltage level and consistent. Goes into the strip, and the strip is basically a big chain of microcontroller-driven LED triplets. When are you gonna set up the area up? After I get this, has to be reduced into a small little board that I can like mount on the wall or near the wall, because this capacitor needs to be pretty close to the LED strip, and this has got a high current, so I can't just like leave it on my desk like this. I need to like have it in something I can put in like a little box and have more professional plugs like this, for example. This should be the only way in or out of this setup, and not have all these exposed wires. So I'm gonna put it into a little box, then mount the light strips, and then I can have better light. But right now I'm just playing with the lights. Mostly I'm working on the control program. So the code here is actually pretty simple. It is. I was showing this before. There's an enormous buffer with all of the bytes of data that get fed out the serial interface to the chip, which happens to look like, it's kind of hard to show this all in the same way. There's the SDI is the data line, and there's the clock line. Basically, every time the clock toggles, the LED chips accept in the next bit of information, and then the information bits are in this format where the first 3 have to be 1s, and then where it says global here, that's the brightness level from 0 to 31. And then 8 bits of blue, 8 bits of green, 8 bits of red. And then because they're in a string, a chain, you mark the beginning of the chain with a special start frame and the end with another special start frame. And technically this is wrong. We found out that zeros work better than 1s, and you have to have as many 1s as the number of LEDs divided by 2. So I have 144 LEDs, need 72 0 bits. So instead of 4 bits of all 1s, I ended up putting in just a bunch of zeros here for the end frame. And we've proven that works. Hey there, TS Just. Did you just get here and you not see my LED strips? I can run it one more time. Voila. So if you want to see how this is assembled, you'll have to go back at the VOD. But suffice to say, brightness... how do I show this so you can see? 20 down. Yeah, now you can see the brightness. If I set this to... I'm not going to go beyond 4 because it's very bright. And then I assemble and run that code. It lights up. And I can even play with the colors. Let's make it a slightly different color. I don't know what color I just picked. Ooh, I picked yellow. Or I think pink was 22 on these two, right? You can say now it's the chicken's color. So rather than having to hack these numbers in and rebuild and run the test program, I'm trying to make this code live in a little web server. That's what I'm working on right now. Didn't know we're playing with LED strips? Yep, playing with LED strips. Doing this via C and Raspberry Pi, yes. So here's the Raspberry Pi, whose terminal window you could see earlier right up here, where I'm running VI in one of the terminal windows, and the other one I'm actually building and running the code. So that's all on this, basically that chip in there. Over the ribbon cable, into this proto board, level shifter for going to 5 volts. I have a little LED sitting off of here because I was playing with just getting familiar with how to use this equipment because it's been years. And then, yeah, I have the whole power setup as a separate thing just for safety, using, keeping my distance between power and ground and using electrical tape so I don't short anything. And then, so the power comes off of this board, the level shifted data and clock come off the other board and go into the strip. Yeah. So it's technically this one's C. My code isn't that I'm doing over here is in C++, but there's really not that much of a difference between the two, right? Okay, I pushed that, right? No, I didn't push it yet. I went to remote add origin HTTP, no, git at github.com, Raimu8354 lighter. Git push u origin master for the first push. So all the code is now available in my GitHub that Aiden Garth linked earlier, and now I should be able to go to the Raspberry Pi and pull it down. So I'm going to leave this. Actually, let's have a whole new terminal window. I can open as many terminal windows as I want since it's Linux, right? Let me set it up with my key off screen so you can't see me accidentally leak my own keys. I have to do what? Eval SSH agent, and then add my key, and then clear that, and then here we go. Nice new terminal window to Buddy. Then my Raspberry Pi, his name is Buddy. So I'm going to go to projects, and I'm going to do git clone git at github. Why do I keep wanting to write githum? Raimu354 lighter git. Oh, and I don't have my own Mugget tools. I need to get that. Pip. Do I have pip? I don't have pip. Do I have Python? I do have Python, but it's the wrong version of Python. Python 3? I do have Python 3. Okay, so do I have pip 3? How do I get pip if I don't have pip installed? Ooh, I didn't anticipate this. Installing pip on Linux. Or actually, it might be, let's see if I can do, can I do sudo apt install pip? Nope. Well, that was a good try, I guess. Installing pip on Raspbian. There we go. Do I need to do Python 3 pip? Yeah, Python 3 pip. There we go. Python 3 pip. There we go. This actually might interfere with the stream since I'm downloading, not uploading, so it should be good. Yeah, I started with a minimal build of Raspbian a couple weeks ago on this thing. Okay. All of this just to get my multi-git tool. I didn't think it would take this long. Why is it so slow? And then how do you run it? Is it pip 3? Python 3 m pip? You just redid your Pi today to get Node.js working so you can have a bot? I see. What are the Why did the bread not go to the doctor? It felt butter in the morning. Oh, Mr. Balrog. Okay, 99%. We're almost done. Okay, so then is it pip 3? Okay, why is it not doing anything? I guess it was waiting for something. Pip 3 install Mugget. Is it gonna work or is it not gonna work? Oh, there it goes. Collecting it. Downloading it. Cool. So then I can do Mugget. CD to lighter. Mugget select main. Why is it not in the path? Oh, the script is installed in local bin, which is not in the path. Okay, so I should add that to my path. Echo path. Set path equal. I guess we'll try these ones first. And then home pi dot local bin. Mugget select main again. I misspelled pi, didn't I? Okay, what am I doing wrong here? That's weird. Did I not spell it correctly? Home pi. Do I need to have a slash after it? What did I do wrong? Oh, you're right. Thank you, Toulouse. You don't want to have that $sign in front. There we go. Oh, it still didn't work. Oh, do I have to not do set but export or bash? That's probably what it is. I get kind of rusty when it comes to Linux. So then Mugget pull will give me all the other repositories. There we go. Pulling, cloning. Now I did make sure CMake is installed. I did at least that before this stream. I should be able to build this stuff, but if not, then I don't know, maybe I call it early. This should build though. There's nothing Windows or anything specific. So make directory build, cd build, and then cmake -g ninja ... Uh-oh. Oh, right. That's that other problem that I ran into. It's a bug with Mugget. I have to select main again. From this... Let's start over with the build. Mugget select main again. So it's got to get the correct branches of Google Test and zlib. Then make the directory build. Then do the... generate the build system. And then it should work. You want to add that to the bash RC profile? Yeah. I just wanted to quickly get it done right now. I don't want to waste too much time. So then cmake -- build dot, right? There we go, building the little web server I made. This is just to confirm that I can actually run my own web server on the Raspberry Pi. Then I still have to actually write the code that goes into this main program. That instead of just saying, okay, PogChamp, it was actually going to control the lights. That's the last piece. And I can't actually test that on the Windows because I don't have the same header files. So, and of course I don't have the light strip, so yeah, there's that. It's gonna... Oh, no, there's an error. What's this error? Is it just a warning? It's just a bunch of garbage to me. It's still building though. Maybe it's just a warning. It's still building. Can I scroll up and see the error? No. It keeps scrolling me back down. I'm hoping that it's just a warning. Because if it's an error, then I have to try to figure out what's different on this version of GCC that I'm running. I can't even interpret any of this stuff. It's just a bunch of gobbledygook to me. Parameter passing for argument of type standard initializer list changed in GCC 7.1. Does that mean it's just a warning? It's saying a standard initializer list. Okay, now it's scrolled again. I think it doesn't like the fact that I'm using certain things in the standard template library. Hey there, Lux. No, I'm not trying to hack the NSA. I'm trying to light up this light strip, but doing it through a web server now. So I'm building a little web server program I made just to make sure I can build it on the Raspberry Pi. So again, what we're doing, building a web server on this little guy that can send the right data over the serial data line to light up this LED light strip when I tell it to. So I've been doing this manually so far. I guess I can demo it since we're waiting anyway. So there's a little test program that I got off the web, which is in this other window, where we can set the brightness and then the LED colors light. So let's turn them on. Build it and run it, and the light turns on. And I had the colors set to pink. Let's turn it off since it's actually very bright. So rather than having to hack this code, build it and run it whenever I want to turn the lights on and off, I want to do it in a web server. That's what I'm working on. It's actually linking it. That's a good sign. What terminal am I using for the git push? Okay, I'm using two different terminals. For talking to Buddy, my little Raspberry Pi, I'm using Putty. P-U-T-T-Y. And then for when I'm working on Windows for this stuff, I'm using ConEMU. ConEMU. All right. Oh, it actually built. Okay, so that means I can run it, right? Lighter.lighter. Oh, it's running. Cool. So now, back in the web server, if I reload, PogChamp. Look at that. So we're talking to the Raspberry Pi through the web. So, now to have it control the lights. There's the tricky part. I need to grab some of the code that's in the other terminal window. And I need to make it conditional so it only builds it on Linux. Yeah. First try. But there were a whole bunch of GCC warnings, so I don't know about that. Oh no, I leaked my internal IP address. Now you know what the address of Buddy is. Oh, you can't even see it. Sorry. We're showing the hardware the whole time. Leaking internal IP addresses. All right. So what if we just have it like one of them turns it on, and one of them turns it off? Let me see if I remember how to do this. I think I just put a string here, right? On. We'll say PogChamp, and then we'll say off is feels bad man. No. Viable thump. And I didn't mean to hit that key. We're building that and just making sure it still works. So back to this window, go to the build folder, go to lighter, and then run lighter again. Okay, and then it's not going to be on Buddy, it's going to be on localhost. Not 3000. I want 8080. Slash on. PogChamp. Slash off. Bible thump. Okay, so I have two different paths set up, or resources. One to turn them on and one to turn them off. Okay, so then let's just keep it simple. Let's have a function that actually just accepts a brightness for now. Where I want to put it, I don't know. Let's put in another file that's conditionally compiled. That would be the right thing to do. In the CMake lists here, have it say if it's Unix and not, yeah, so for Linux basically, to add to the sources. How do I add in CMake? I forget how to do that. Oh, I know where I've done this though. I've done this in the system abstraction CMake file. Yes. List append, that's what it is. So if it's on Linux, list append to sources, source Linux, what are we going to call it? LEDs, I guess. And then well, let's do the full thing. I need to have some kind of stub for Windows, right? Let's just say else. Can I do an else? Else. And then I guess I have to put that condition there. So this will be stubs. And then I'll want to have the header file here. leds.hpp. Okay, so let's establish these files. There needs to be an leds.hpp. There needs to be two subdirectories, one Linux and the other one stubs. Or mocks or something, I don't know. And then these both have to have an leds.cpp. leds.cpp, right? So one of them is going to be built for Linux, the other one's going to be everything else, and there's going to be a header, which is in the wrong directory. Put that back into source. All right. Okay, so keeping it simple, right? So let's just say pragma once, and then void. Let's just put them in a namespace. Namespace LEDs. Extern void turn on. Just keep it really, really simple. Turn on, turn off. Okay, and then in the stubs, let's just have it print something, I guess. Yeah, well, actually, it's not doing anything. I can just have it print, sure, to the console. Why not? What am I doing? I need the whole thing. There we go. And then we need to pound include .leds.hpp. And I don't need to repeat the externs, right? So I just need to do something here. And we'll include standard IO just to print something. Light up. And this printf will be too bright. My eyes. Okay, let's no, I want to still have a joke here, but not it's when we're turning it off, right? Thank you. Thank you. I almost went blind with that. I almost went blind there. The all caps is very important. That's how you make the code work. What do you say in a sitting competition? Last man standing wins. Okay, that's an okay one. Okay, so I'm gonna have the same thing on Linux for now. Let's just make sure that this builds. So in on, I basically just say LEDs turn on, right? And then this has to include LEDs. Turn on, and then off is turn them off. Okay, and then build it. And then I need to stop the server for it to build. And then start it again. Okay, and then when I do the off, it says, thank you, I almost went blind there. And then on is light them up. Okay, cool. So now the trick is I have to put the Linux code in there without being able to test it. Because I'm running on Windows right now. Get it over to the Raspberry Pi, and if it doesn't build or has some other problem, then I will debug it there in VI, I guess. So, LEDs in Linux. We're going to copy from the example source code here. Essentially, we need a buffer of some kind, right? So, standard def.h, or is it standard int, right? Actually, it's always good to include standard def. No one will mind if we include standard def, right? So this lockdown, does that make us all homies? Okay, you get a half point for that. Okay, so what am I doing here? I need this. I need the important one, which is 50 down from here. I need this structure here and this IO control. And I don't need to print out the results. I just need to capture that and paste it here. Let's have another one in an anonymous namespace where I paste that stuff. So here's where we set up this. Okay, hold on. That's where we're actually going to use it. So we're going to have a function here, set LEDs, and here I'm going to have the brightness, red, green, blue. Okay, and then setting up our structure. Is this because it... Okay, yeah. Right, we can't debug this. We just have to hope it works. So I need to set up the... Why does it need to be an unsigned long? Oh, it's an array. Okay, so we need to set up the actual structure here. So it was 4 bytes for the start frame, and then 4 times 144, and then 12 extra. So let's have this in a vector. Did you know that Michael Jackson had a denim store? It was called Billie Jeans. Okay, that added up. That's another half point added up to a full point, Mr. Balrog. Thank you very much. While I'm at it, actually, while I was looking at this file, let me grab the headers. I don't know if I need them all, but why not just grab them all? Paste. Whoops. Paste. Standard int we already had. unisd, sure. We might need that for something, right? We already had standard IO. I guess we might need standard lib. We don't need getOp, I know that. We need fcntl. And we definitely need IO control. Linux types and spydev, and we at least need the spydev, right? Okay, so one of these, probably this one, gives us the definition of the structure. So the TX, so we need 2 buffers of uint8 TX, and that's going to be 4 plus 144 times 4 plus 12, right? And then the RX has to be the same size, so let's just say RX is TX dot length, or size. And then this will be TX and RX dot data. And the length is TX size. And then these ones I don't have yet. I need to find out where they come from. There's one of your LED strips? Oh. Nifty. So you have it behind the shelves and stuff? Cool. Neato. Connecting to Wi-Fi is when it's moving back and forth? Nice. What do you call a vegetarian Viking? I think I've heard that one before, but I don't remember it. Norwegian? Norwegian. Alright. Yeah, you deserved a not like this from TS Jost. Okay, where was... Okay, it's just static. Alright. Now what about delay, though? Where's delay set? Is there a default delay? If it's not set, does that mean that it's 0? Hold on, what did it print out? It's not printing out delay. I don't know what to set for delay. I guess it'll be 0. Delay is 0. Speed 500 kilohertz. Bits per word 8. And then IO control, we need the file handle though. And then let's make this have a Boolean. So the way this worked is If it's less than 0, is an error. So we should say return greater than or equal to 1. And fix the indentation here. Actually, the indentation's correct. I just need to terminate there. So that's it, I think. Oh no, I have to construct the contents here. So this will all be 0 constructed except for the internal. So we're going to say for size ti is 0, I is less than 144, plus I. Tx 4 plus I equals OXEO ORed with brightness. Right? And then Tx4, let's just say I plus 4. I plus 5 is blue next, right? And then green and then red. 6, 7. And this will loop 144 times, so this should be I times 4. Right? And I think I got it right. Gonna be room lighting. It's gonna be lighting for the stream. Also, possibly controllable by chat, Jabico. I at least want to have good lighting on my face, so that I can stream at night and when it's cloudy and not have trouble with the blue screen. Although if I let you guys control it, you're probably gonna turn it blue and then make me invisible, but that's okay. Yeah, my son says I shouldn't be giving you guys any ideas. Okay, so the idea is to use this from here. Instead of printing F, we'll do set LEDs 0, 0, 0, 0, and turn, let's turn off actually. Turn on, let's do 4 brightness, and then let's do the pink. Let me review this. I need a file handle. I forgot that part. FD. Okay, we have to open the device handle. That's easy. It's just an int. Okay. So int FD is open, and the device is dev spydev 0.0, right? Dev /dev/spydev 0.0. And open read write. If FD is less than 0, then we're going to return false. Tim had green screen for one stream. The next day he forgot to remove the chroma key, which made Monkeybird invisible. And everything saturated. That's funny. And make ghostly blue see-through Spectre. Yeah, why not? Okay, so we've opened the device. Oh, I have to do this stuff too. Spy IOC write mode, read mode. Where is mode set? Where is this set up by default? I don't have any options, so what is it doing? I guess it's 0. I think what it's doing is it's writing a 0 and reading it back. Okay, I guess I want some of this stuff then. Let me grab it. Oh, it is printing the spy mode. What is it printing? 0! Alright. So let me grab all this. And paste it over here. Paste. Okay. So then, I don't need to read it back, right? I can just, what's ret? What's ret? Ret is an int. Int ret. Then return false. So I'll probably, if we have errors, I'll make this more elaborate later. I just want to get this off the ground. We'll just, I'll get rid of all the reads. We're just writing to it. correct. Okay, so we set the mode. Mode has to be 0. I guess we'll set that up here, right? How come the transfer had to have the speed as well? Weird. Okay, so I guess we'll put that up at the top here. Mode 0. What did they use for speed? Oh, the mode was a uint8. uint8t. And the speed was a uint32. So that speed goes in there. And then bits was the uint8. I suppose this can all be const, right? Bits. I'm not going to worry about delay. I don't think we actually ever write delay. We write speed, bits, and mode. You know what's interesting is... Oh, it's just taking the address of it, right? We let the IO control deal with how long it is. Yeah. Okay. On error, continue next. So this is all keeping the same spirit of this. So push data out the SPI to the light strip. Okay, so setting the mode. These are all set. SPI mode. This ought to be capitalized. Set bits per word. Set max speed in hertz. And hertz. Push data out to the SPI to the light strip. Did I get anything wrong here? Or the FBI likes to push data out of spies too. Okay, you get a point for that. And then we want to close it at the end, right? So this should be const auto result. Actually, you know what? I'm not going to do it that way. I'm going to do a silly little trick using memory. Memory. Pound include memory. I'm going to use a unique pointer for the file descriptor. So use a unique pointer to auto close the file upon return. So we'll have standard unique pointer to an int, and the signature of the deleter is standard function, which I need to have functional. Standard function, which doesn't return anything but takes an int, right? Takes a pointer to an int. FD. FD closer. So we give it the address of FD, and then we give it the function which takes again the FD and does an F. Is it F close? What do they do? Close or F close? Probably close, right? Yeah, close FD. Close FD. Pointer. So we'll be given a pointer to it, actually. All right, so given the address of the file descriptor, upon this being destroyed, it's going to dereference it again to get the original file descriptor and pass it to close. I think that's all I need to do. So then if we return at any point here, I'll just close the file descriptor and exit out. Okay, so then do I need... I'm not even using the return values here, am I? Let's have it print something. If not set LEDs, fprintf standard error. Feels bad man. I hope never to see that though. Okay, I can't actually build this. If I build it now, it's not. It won't even build this file. I need to actually check this in and try to build it on the Pi now. Okay, so adding add code to drive. That's not capitalized. Add code to drive LED lights on off. Commit that. Push it from there and then pull it from the other place. Git pull. And then cmake build. Okay, I have an error. In set LEDs, the designator order for speed hertz does not match declaration order. What did I screw up there? Line 43. I didn't change any of that, did I? I didn't think I changed that. So what did I do? Speed hertz. Is it something where it's allowed in C, not in C++? Let's just do this. I don't like doing it this way anyway. Let's just do it a different way. tr dot. Let's just basically change all the commas to semicolons, and then put tr dot in front of all these. And then we're done. There. Oh, I can't build it, can I? I should have just done this in... I don't have VS Code on the Raspberry Pi, though. So, hopefully, fix Linux compiler error. If this doesn't work, then I'll just start using VI, like a hacker. Other window. Git pull. Make. Oh, there we go. Second try. So now I have to run it as super user. Build lighter. Okay, it's active. It's active. So if I were to go and turn it on here, /on, it didn't do anything. What did it do? Feels bad, man. Okay, something failed. Failed. Oh well. So I guess I should have had a printf for every failure point. That's what we're gonna do. vi Linux lighter Linux. What do I call it? Source Linux LEDs. Vi like a hacker. So let's say here fprintf error opening SPI device. Yank, and then down here, error setting SPI mode. And then I need to do that before the return. Yank, paste, error setting SPI bits per word. Error setting SPI max speed. And then let's add one here. If it's less than 1. Is that what the code originally was? Yeah, if it's less than 1, then you couldn't send it. fprintf error sending SPI data. Return false. Return true. Okay, then make it again. What did I get wrong there? Oh, I didn't put... I know what I did wrong. fprintf. All the fprintfs have to have standard error in front. How many times did I make that mistake? I don't know how to do multi-cursor in VI. Spy data, yeah. It's on the SPI bus, the serial peripheral interface. Okay, build. Linking. Done. Then sudo run it. Then reload here. Oh, there's no error that time. Now it works. What did I do differently? On and buddy.local off. Off. On. Off. On. Off. On. Off. I don't know what I did. I thought I just added fprintfs. Did I not run it as super user maybe? Initialize a slow part? I think I just forgot to run it with sudo. I don't know. I don't know why it failed. You can select a block. You can block select and then C for change the type something. Escape to apply the edit to all selected then. Yeah, but this assumes, Nui, that I really am interested in learning more VI, and I think my brain can't hold on to that much information. I did do sudo, so, well, if it happens again, I'll see what the error is. And to make it even better, what I should do is I should funnel the error back into the response somehow. Preferably in the, do you put it in the body when it's an error? I need to look this stuff up. I don't know how to do this. But hey, look, I can control my lights through my web browser. Now maybe we can work on doing... okay, I should push that change, right? Control C, git... I don't have git GUI. Git status, git add all, git status, git commit m... what was the difference, actually? Diff stage. It's diff with, what's the option that's diff with the stage? It's diff cached? Yeah, that's what it is. I just added fprintfs. That's the only thing I did, right? Maybe maybe I had this wrong here. I think that's correct. I don't know what I did. What I did didn't seem to do anything other than add error messages if we see them. Who knows? Okay, git commit add error message logging. Git push. And then back here, I can do a git pull. And then work on a little bit more sophisticated stuff. I don't know how much longer I get to stream. I think I might have a meeting for one of my kids' schools, an online meeting, but I don't remember when it was. I guess I could look it up right now. Hold on a second, let me look it up. I think Mrs. Reimu did put it on my schedule, so I just need to look at my calendar real quick. Oh, I guess not till another 2 hours. So I got plenty of time. All right. Cool. Strip is still covering. Oh, I'm sorry. Sorry about that. I wanted to see the lights turning on and off, though. Is the page running the Pi? Yeah. That's why I was showing this. So if you do the slash, I don't know how to make it bigger, the address bar bigger, but it's buddy.local:8080/on. If I reload that one, okay, I'm not running the server. I need to run it. I stopped running the server so I could check into Git. If I'm running the little helper, and then I do the on, then it comes on. If I go do /off, it turns them off. So now I wanted to make it so that I can set the brightness and color through the query. Body should print the request URL as the top line. Oh, we can do that. I like that idea, Jabico. Point for you. Let's do that. Where did I put... Is it in the same file? Yes. So we'll just print... No, it wasn't here. It was in the main, right? Yeah, so that means I can test it on Windows, which makes sense. So instead of PogChamp, let's do a string extensions. I don't have that included. String extensions. What cat is good at do-it-yourself and brightens up the garden? A handy lion. I don't know about that. Okay, good night, Nui. Thanks for being here. Hopefully this was entertaining. I don't know about that, Mr. Balrog. Handy lion? Okay, string extensions, printf. We're gonna print what? I want to print the request. We're gonna do this in a couple lines, right? %s rn. Actually, we can just have that for now. The request is going to be request dot. There's a way to encode it, wasn't there? Oh, it's not. Okay, it's target. Request target dot generate string is what it was, right? There we go. So if I just run that and stop the web server so I can build it, and then run it again, then it didn't print anything. Why not? Oh, did I put it in off? I put it in on. That's weird. Why did that not work? F12, that guy. Where's the response? It was an empty string? That's weird. Why would it be an empty string? Huh. Maybe this generate string doesn't really work. It should work, though. Well, why would it be empty? Huh. The target, oh, it would be empty. No, it should be /on. Oh, no, I would separate it. No, well, wait a second. I'm jibber-jabbering. It should have constructed the path part, at least. It should have said /to, or /on for on. Okay, unless it's not in the target. Hold on. I'm getting another spam call. Goodbye, spammer. I don't know, it's weird. Can I at least print the method? Method. URL, URI. So request method C-string. Oh, that's right. Can't run it while it's being built. Can't build it while it's being run. Reload. Okay, I'm doing something stupid. What am I doing wrong here? Oh, there's a comma there. Yeah, no comma. Yeah, the URI is empty. Why would that be? I guess it's a bug in my web server. I just never saw it before. I guess I'll have to track it down. Server. There's register resource, and that goes into resources. And we pull that back out when a request comes in, right? Right here. Request target does set the path. It should set the path. to resource path begin. Oh, wait a minute. Hold on. That's right. No, wait a minute. That should work. Shouldn't it? Or parts actually run compile from VS Code, which are run the Pi. It's the same program, but I have it split so that there's a version of the LED, the turn on, turn off, that runs for Linux that actually does the lights. But when I run it locally on my Windows box, it just says these things on the console. This is so I could separate the actual test, like I could test as much as possible without the LED strip. Yeah, it's an emulator. The emulator is it prints it to the console. So you see the light them up, right? And then if I do off, it'll say, thank you, I almost went blind there. Yeah, the on though, it's not saying on there. What if I did on hello? Okay, so the path part is not being included there for some reason. That bugs me because it should have been included. Because I have it there. I'm wondering if it has to do with, well, what if I do an on slash? Oh, that's right. It's the sub path. I remember why I did this. I wanted the attachment point to be independent of the resource handler. So if I had like on slash ABC, it just prints out ABC. But if I do on ABC DEF, or yeah, that's DEF when I have my hand on the keyboard wrong. So it strips out the beginning part. Now I remember that. All right. Hey there, Anakin Luke. Have you seen my light strip? Check it out. I can turn it on like this, and I can turn it off like that. How's quarantine? Pretty good. I assembled all this prototype stuff right in front of me on stream today. I am making a web-controlled light strip. And I'm just keeping it simple now. So now that I figured that out, what I wanted to do with this was use the query part, right? So let's just say query. And it's not the generate string, it's get query. And stop the web server, build, and then I need to run the server again. Query, okay, so on, let's say brightness equals 4. And is it, it's and, right? Color equals FFAA00. Okay, so we can't use the hashtag because that's a fragment, right? So what's the code for, what's the ASCII code for hashtag? How do we escape it? Anybody know off the top of their head? I guess I can do lookup ASCII. I need a quick ASCII chart. Okay, you got it faster than I could. Let me confirm. 35, right? 35 hex. I'm still looking at it wrong. And aren't I? Is it 35 decimal? 35 decimal, yes. Okay, you are correct. Thank you, Jabico. So, back here, I don't need that anymore. It's, that's how you do it in HTML. I think the way you do it in a URI is with a % and then 2 digits, right? So, that would be, 23, right? There we go. %23. It has to be in hexadecimal in URI. Okay, so then if we're gonna split it, yeah, let's make it. Let's keep my life simple and keep it short. And we don't. Let's not even put that special character at the end. And let's then have this split. Okay. So then const auto. Do I have string extensions? Yes, I do. So params equals request.target.get query dot split, or split, string extension split. It's the string and then the delimiter. So that's the string, and then the delimiter is the and sign, right? Yeah. And then let's construct the response somewhere else. So stream, I guess. Oh, I already have stream. What am I doing? Standard O string stream is a buffer of some kind. Buffer, we'd say query, and then this part, and then for const auto param and params, let's say buff that is that, and I want, oh, what am I doing? I switched back, I reverted back to thinking of printf. Key equals value, and this needs to have a -r-n, because at the end what we're just going to do is just say the body is buff.string. Okay, and then the key is going to be a actually I can do it this way. Const auto key value is string extension split param on equal. That can be one line, and then const auto key value, or key value 0, and then value is 1, and then only if key value dot size is less than 2, continue. All right, build that. Repeat. There we go. Okay, and then now I've separated the brightness and the color value, right? So then let's pull apart the color. So let's say up here, brightness and red. Well, I should use the same types, right? Standard, yeah, okay, standard. So these should all be uint8t. So let's just default them: red, green, blue. And then we'll say if key is B, brightness equals value. We need to interpret the value. So that's void scanf value c string. Format is %scnui, and that are u8. And to get that, I need int types, right? Include int types.h scanf, right? And then the address of it, brightness. All right, and then else if it's C, then I want to scan the colors in, right? So that's let me think about this. Ultimately, we want red, green, blue, right? Green, blue. But I want x8, right? And I want %2x8, I think. I think this is what I want, but I'm not sure. And then, yeah, I didn't have any prefix in front, so it's just that 3 times. I think that's what I want. Or is it O2? I think it's just 2, right? How do you make a tissue dance? You put a little boogie in it. All right, Mr. Balrog, come in with the points there. Okay, so let's have it brightness. Brightness. And then here, if we scan it correctly, let's do the red, green, and blue. Okay, let's just doing incremental. Since I'm not doing Google test, I'm just sort of hacking. I'm just doing successive steps here just to get the things I want. Why did it do that? That was weird. It gave me a file of some kind. Why did it give me a file? Monka S? Let's see. Open it in Notepad++. Oh, because it's got junk in it. It's not text. Okay, because I didn't... Oh, because I didn't... I'm using the stream operator to push it out, and I'm not formatting it correctly. To do that, I need to put int in front, right? Build there. Go there. Refresh there. There we go. That looks correct. Cool. So then I don't need to actually print out the raw stuff anymore, right? Actually, I guess we can see that for yeah. Let's print this out first so that you guys can see what it's actually decoding. Why do I keep hitting F7 in that window? I don't know. So that you can actually see what query I'm using, and then it kind of interprets it, brightness for red, green, blue. Okay, so then the last thing would be to update the LEDs thing. Thank you for that follow. So to have this one take those parameters, right? Uint 8T. So we're going to want to include standard int, and this is brightness, and then red, green, blue. Right? And then we'll have the mock, I guess, just print them out. Brightness, percent, and so for this I need int types again. PRIU8, and then end line, brightness. And actually, let's just do the color directly in here. No comma there. So this is PRIX, so we'll put that in front. And then repeat it again, I suppose. No, we want O2 in front, right? And then another one. And then it's red, green, blue. O2, that. Do that. Yeah, I think that's right. Okay, let's build that. No, I need to update the main, right? When we turn it on, we have to pass the brightness red, green, blue. Okay, and the default, if you don't have any query parameters, just turns it off. Okay, line 11 is wrong because I had an extra comma. There we go. Connect this to Twitch channel points? Yeah, probably. Something like that. Although I might have to limit the parameters of what you can do because I don't want to... The whole point of the LED strips is to keep the blue screen running well. Thank you for those bunny ears. Okay, brightness for the color is correct. Okay, so I think I'm ready to actually update the Linux side of things. So that means going to the Linux side of things here. So turn on now looks like that without the extern. And I don't hard code these anymore. I just simply plug them in. Right? And I'm not going to handle the error path. So this should not break, but I can't really test it until I there's no reason for me not to keep running that. Okay, so allow brightness and color to be controlled by the client. Commit that. Push it. And going over to here, get pull. And then build it. Where's the build? There it is. Oh man, I had a build error. So that's lighter source Linux LEDs line 104. Yeah, I forgot this little thing. Okay. Forgot one end parentheses. Linking. Okay, get status, get diff, get add dot, get commit, add missing parentheses. Get push. All right, let's run it. There we go, running it. Okay. So, I just need to form the query parameter in the on here. Cool. I didn't make it pink because pink is actually OOAAFF, right? No, that's blue. What was pink again? FFOOAA? Oh, AAAA. There, no, that's not right either. AAFF? I'm not getting it right. Why is that not showing right? Did I mess something up? Let's just do red only. That's red. That's green. That's blue. So why can't I get pink again? Wasn't pink FF... Oh, it was 2222. That's right. There we go. There's my pink. Red, green, blue, yes. And then if I want, I can make it not so bright. Or I can make it really bright. Ah! Or I can turn it off. You like it, Geno Hacker? Yeah. Web-controlled lights. What else do I want to do with this? I guess to get any more elaborate, we want to have some kind of animation, right? How about we do something... Yeah, how about we do that just for fun? Since I can still go... You guys are having a good time, right? I should continue working. Let's put in like a flashbang thing. What do you think? Flashbang? So we'll just add another resource here. It's quite fun. Yeah, I'm gonna probably be doing this all day, having fun with this. So flash. What if I have the query stuff offloaded to another function? Yeah, let's do that. Let's pull this out. Let's put it right here. We're gonna have it return LED params. Parse LED params from const std string query. There we go. And then LED params is going to be a struct. And it's going to have these fields in it. Like that. And then, so this is just query now. And then, yeah, we're not gonna do this here anymore. Oh, wait a minute. What if we wanted to? Yeah, let's have it return that in the parameters, maybe. For debugging only, or for showing chat only. Really, for showing chat only. We love you, chat. So that would be standard string response body. Okay, and then so we'll put the query in here. And then in front of, okay, we need to make one of these LED params. Let's name it something else. How about no, that's okay. LED params is fine. We just have to use the full name to not collide with the other word params. Okay, so in front of brightness, red, green, and blue, I'm putting that structure, right? There we go. And then we're going to return it at the end. And then the buffer we have to put into LED params. Response body equals buff string. Cool. And then I just need to call this from here. Const auto LED params equals parse the request target query. And I don't need any of this stuff, right? And then we turn it on based off of those parameters. Dot. And then the body is that dot response body, right? And then, what did it not like about that? Oh, there's no parentheses. Okay, Flash. Coming soon. I just want to make sure that I didn't screw anything up there. Let me verify. Trust but verify. Yeah. Still correct. Okay, so then flashbang. Let's add a parameter here. No, I don't need a parameter. I just need to parse it again. That was the whole point of doing this, right? Is to parse it again. Right here. And we're not going to call turn on anymore. We're going to call flashbang. There we go. And this will be omega lol. Actually, what am I doing? That is not from there, it's from here. I don't know what I'm doing. That goes there. Flashbang doesn't exist yet. Let's make it exist. Actually, they're just copying this turn on to be flashbang. Or do I want to build it into turn on, actually? Well, turn on sets the... Yeah, okay, I don't want it to build it in. I want this to have it take longer. 20 for brightness for 250 milliseconds? Yeah, we'll figure something out. That's the specification there. Here, we're going to put it. And we'll prototype something here where we will then copy it over to Linux. Okay, so I think what I want to do is run an asynchronous process for this. Is that... I always forget this. I forget a lot of things. It's C++ async. Which header is this in? Future. It's from the future. Oh, from the future. And there was a problem with this where, if you destroy one of these async, it gives you back a future, right? And if you were to destroy that future before the async is done, it actually synchronizes, and we don't want that. We want this to trigger a flashbang, which might take a while. So I think I'm just going to cheat and have a global pointer, or we could use a static. Static means that it's going to keep its value from one run to the other. And it only gets destroyed when the program exits eventually. So this would be a static standard future. And then it's whatever I want for the result of, right? So it's just void of... so this is flashbang future. And we're going to want to reassign it. I don't think we can do that with the future, can we? Oh, maybe I can. Let's see if it'll let me. What I want to do is do a standard async, and I'm going to totally cheat again. Oh, wait a minute, I can't because I had to restart. I had to restart VS Code. I'll have to open up a new window. I'll still totally cheat. It's just going to take me a minute to reopen my other project. I'm going to totally cheat by looking at when I did this before. Yes, I did here. Right. So there's like boilerplate stuff you have to know. Like you have to say launch async, otherwise it's not guaranteed to be asynchronous. And then you can do whatever the heck you want. And what you get back is the future, which we can put here. And then, actually before that, like if we flashbang twice, we can actually have it wait, right? Actually, no, it'll just abandon... No, really, for the real thing, I'd want a queue or something. But let's just have it wait. So if flashbang future dot valid, then flashbang future dot wait forever. Okay, and then in the asynchronous function, let's just capture everything. What I really want to do is, what do I want to do? Have it go on immediately and then go off? What if I have it go on immediately and then taper off to nothing? Really, I want to have it do a script of some kind, don't I? Yeah, what if we just totally program a script in here? Static, let's make a vector. And let's define a structure. So struct, can I do it one step? I think I can. Static struct of some kind. Well, no, if I want to no, it could be an array. Right, so the array would be what? Script. And then like that, and then the fields of the structure would be, what am I looking for? The amount of time. So let's keep it simple and do a standard size t of milliseconds. Yeah, milliseconds. And then brightness. And then I'm just repeating this stuff up here, right? Actually, then flashbang. Now for flashbang, we won't have anything in here other than brightness. Just keep it simple then. All right, and then so beginning at 0, we want full brightness, right? And then after what? I don't know, let's say a half a second. What did you guys say? 250 milliseconds? After 250 milliseconds, have it taper off to 8. And then maybe maybe at 30 millisecond intervals, drop down. Like this. 5, 4, 3, 2, 1, 0. So so basically I'm writing an animation script in a sense. 5, 5, 6, 6. So it's gonna take this long to finish. So go to full brightness right away, and then a quarter second later go to 8, and then after every 50 milliseconds go down 1 until we're done. After you bought your car, you got sick. I guess you could say you got the car owner virus. Car owner virus. -1 point, Mr. Valrock. Okay, so what we do here is we say for, well, let's pre-compute the length of the script. This is constant, right? Static const script. So const expression steps or num steps. This is the size t. Can I do an auto here? I don't know if I can. It would be size of script divided by a size of one of the scripts. And that should be a size t, that's 10. Yeah, 10 steps, right? Cool. So then for size t I equals 0, I is less than num steps, plus I. We're first going to wait, so standards, I need thread for this. Include thread. Can't type right now. I think flashbang is going to leverage turn on. Yes. So standard this thread sleep for standard milliseconds or standard chrono milliseconds. So let's actually get a reference to it. Step equals script I. So this would be sleep for step dot milliseconds. And then turn on step dot brightness and then red, green, blue. So it's not going to change color, it's just going to flash on. So this will run asynchronously, and then if it runs a second time, we'll first wait for it to finish and then do it again. Let's make sure this builds. So a million things I could have done wrong there. It built. How about that? Okay, let me test it. Where's my Chrome window? There it is. I was using it for this. Okay, so then let me make a new window, which is Flash, right? And I think we're ignoring the brightness, right? It's just got a color in there. That was very slow. I didn't like how slow that was. That doesn't seem like 50 milliseconds. That seems like 500. Did I get the number right? Oh, this is an absolute number. Right, so don't sleep at all. Wait, sleep that long, and these should all be 50s. I'm just dumb. There we go. Don't mind me. I mean, if you've watched my stream long enough, you know that I don't think through a lot of things. I just try it, and then it's a closed loop system. I try it, and it fails in a way that makes me think, oh, I need to adjust it a little bit, and then try it again. Okay, we might actually want it to take longer to dim down, right? I don't know what exact parameters I want here. Because the LEDs like dim by themselves pretty slowly, right? They have some persistence. Now this is good enough. We can give it a try, right? So then let's have it also print out that well, that was in the query, right? Well, but it doesn't say which one I'm doing. But people know what I'm doing, right? So we'll just make sure I do this in Linux now. Actually, this thing could be generic. It doesn't rely on anything, so I can move this to a generic leds.cpp. Let's do that. New file, leds.cpp at this level. Has what we have in the stub, but, and so it's just LEDs, but only the flashbang one. And not the turn on or turn off. So it has to include... Why does this not like it? Oh, because I don't have it in the CMake list, probably. So, leds.cpp. So the reason I can do this is that they're in different folders. So we have... The main LEDs has the generic code, and then the Linux specific and the stubs are in their own folders, and the linker figures it out. This way lets me do it without having multiply defined symbols. As long as I don't keep a copy of flashbang in the stubs here. So let's remove flashbang. And now the same flashbang script in the generic LEDs is just going to use the Linux specific turn on, but should operate the same way. I don't know why it's giving me a undefined. It is defined. I think it's just confused. No idea about cutting, but so many subscribed to start hosting me, and my guy man just wanted to come and say that my beard and my hair combo is majestical. Thank you very much. Only been watching 5 minutes. I have no idea what you're talking about. What I'm talking about is controlling this fine LED strip here. Raspberry Pi, proto board. We have a level shifter for changing voltage. I have a 10 amp power supply coming in here to this scary looking power supply proto board here, running this strip of lights, so that when I go to my web browser here and I say turn on, it turns on, and if I go here and it turns off. So I was just putting in a flashbang script, which is turning on and off, well, turning on with different brightnesses with some delays coded in there. So we go through this table and we wait for the first number of milliseconds, and then we set the brightness to the second number. So that's what I've been doing the last 5 minutes. So hopefully now it makes a little bit more sense. This turn on is sending, what it's ending up doing is it's sending a string of data along this LED chain, basically. Every LED along the way gets 4 bytes of that data. And right now I think for turn on, we're just always sending the same, we're setting the same RGB values for every LED. But if I wanted the LEDs to have different colors, here's where I would do it. Here's the loop. We have 144 LEDs. If I wanted to have different colors on different LEDs, I would set it up right here. So basically we assemble the whole string of control data and then send it, this line here actually sends it. It goes into the Linux kernel, which will go to the driver for the serial peripheral interface, which is driving this green wire here along this protocol. It's a very simple protocol, if I can show you the right page. So SDI is my green wire, clock is my yellow wire. The Raspberry Pi's serial data interface does the hardware signaling for me as long as I tell it what to put in these bits here. MSB stands for most significant bit. So it sends the most significant, or the top bit of the byte first, and then the next one, and then the next, and so on, until it's sent a whole byte, and then you repeat that for all the bytes in a message. And the message structure, it's pretty simple. There's a special all zeros when you start, and then for every LED you have 3 1 bits, and then 5 bits, they say global here, but it's really the brightness for the LED, and then the blue, green, and then red values. And then when you're done, you're supposed to send an end frame, but we learned that instead of all ones, we actually want all zeros, and we want slightly more of those because we have a long chain. So yeah, 120 volt. It's not 240 volts, fortunately. This is only 5 volts, but it is potentially up to 10 amps. But I think we're only using maybe 2 or 3 amps. But it's enough current that I want it to be a dedicated supply. This capacitor on here is to even out the flow of electricity through it. If it were to, if we were to run some kind of script which is flashing the LEDs on and off rapidly, the power drain would maybe put some strain on the power supply. So this capacitor evens out the power supply if the current consumption varies, like if we're doing a lot of on-off stuff. Anyway, let me know if you have any specific questions, but what it comes down to is this is the software-hardware interface. We say what data we want to give out to the chip. The chip specification says, well, if you put it in this format, and then you give it to me on the wire like this, it'll light up the way you want. The driver, the device driver in Linux that talks to that chip with that protocol, takes the data we put into this vector, and with this command, that's IOCTL stands for input output control. It's sending a message which has the entire block of data that should be streamed out to the LEDs, and it just sends it. It sends it at a very high frequency. I think we had it set to 500 kilohertz. So within like 10 milliseconds, it's either turned on or off or changed the color of every single LED in the strip. And then where it gets a little bit more abstract is what calls this set LEDs. So simply turning on would call it. So that's easy enough, right? But I was just working on this more elaborate script called Flashbang, which is going to turn it on, but with different brightnesses after certain amounts of delay. So it's going to come on really bright, and then after a quarter second, taper down to being off again. And the next level above turn on or flashbang is the web server. So I have a HTTP web server where we have registered that if you go to the flash route on the web server, it runs this code. And then it also generates a response, which is what we see in the browser here, this stuff, right? So this is generated as this response body that I constructed right here. So if you look, some of the text you see there ends up showing up here. This is awesome. I'm glad you enjoy it. Please ask any questions that you have. Either I or someone else in chat could probably answer them. So I think we're ready to test, right? Did I push this? I didn't push this yet. I didn't check it in, so I think we're all ready to go. Okay, so adding it. Add flashbang. Commit. And push it. And then I gotta go over to my Raspberry Pi named Buddy. Oh, that's right, I had a bug fix on Buddy. So let's fetch and then git rebase origin master. And then push. That was a merge conflict because I had checked something in on Buddy. So then on Buddy, we're gonna git pull and build. Where's the build command? Here it is. Here's the build command. Hopefully it just works because most of the code we tested on Windows. Where it might not build is if there's something specifically wrong for the Linux compiler. So if there's some of the Linux code that's different. But it worked, so then we can run it again, and we're ready to do a flashbang. So let's show the hardware again. And I guess I need a new window. Let's repurpose this one. So we'll go to buddy.local. And ready? Here we go. Didn't do anything. Oh, we got that error again. Huh. Error sending spy data. So that's last time that happened. We just re-ran it and it worked, right? Now it's not. Now it's not working. Why would that be? What's different? Yeah, it's not able to send the spy data. I wonder if there's something wrong in that I didn't copyright. Actually, so I can just go over here and run this script again. So that actually ran, right? And now let's see if the other one runs. No, it still can't send it. Sudo is work. So why would... What are we doing differently? Yeah, so there's something unexplained that causes it to not work all of a sudden. Let's turn it on. Let's try turning it on a little bit. And then build and run this one. So it does turn on. But this one can't. Okay, now it's working. What did I do? Okay, it sometimes works and sometimes doesn't. That's weird. Oh, hold on. Maybe it didn't work at all and it just turned it off. Okay, that might be why. Turn it on. No, we're not getting an error. We're not getting an... Okay, but it's not printing anything to tell me. Okay, there's no error turning it off, but there is an error turning it on. Why would that be? The only difference is the data. Did I make a... Is there a bug when we compute the... some of these values here, maybe? I should turn this on so you can see it. This should initialize it to all zeros, right? Then we have 4 for the start. 144 LEDs and then 12 zeros. The RX data is the same as the TX data. This is taking the pointer to the data and turning it into a number. The length, yeah, I don't know what's different here. See one later and the other one in a while. Come on, Mr. Balrog. Very strange. That would work for off, but not on. Okay, that one's turned off. I should just put that one over here. Yeah. Blame the lateness. It could be. What would be different? I'm wrecking my brain trying to guess what's different between setting them on and off. What if I set it on but brightness 0? Do I get an error from that? Yes. What if I set it all to 0? That should be the equivalent of off. So that doesn't make any sense to me. Because turn off is set them with all zeros, and set them on with all zeros is the same as off. Just to help me out here, let me go to here, go to source lighter. How come this is not happening? Not helping me. What's going on here? Oh, lighter source. Linux LEDs. CBP, yes. And let's have it print something when it's successful. I'm wondering if it's some kind of uninitialized variable thing. What am I doing? Yank, yank, paste. Let's just do a printf and not to standard. Oops, not to standard error. I turned them on, sir. Off now. Can't turn them on. Feels bad, man. I want them to look visibly different. What? Can't turn it off. All right, let's build that. Watch, with my luck now, it won't fail. And I'll still be at a loss to explain why it sometimes works and sometimes fails. Web server active. Okay. Can't turn them on. Can't turn it off either now. But the other script works? Yeah, that works. Wait a minute. It did turn it off that time. It said can't turn it off. Did I do this right? Hold on. I think I had the logic backwards. Yeah, you're right, really, Frank. You are correct. So the off is still is working. I had this logic wrong. X. Why can't it turn on the LEDs though? It can only turn them off. The difference is just in the data, not in any of the code. All right, let's turn them on to pink by default. They're pink. You can maybe see it in my face. And then turn. Can't turn them on. Turn them off. Okay. What's the difference? There should be absolutely no difference because I'm doing all parameters 0. I'm not even looking at the right file. Let me synchronize this. Otherwise we'll go nuts. git add dot git commit add more debugging on Linux, git push, git pull. All right. Yes, so they're both calling set LEDs, just with zeros. What? It's just random then. Wrong window. This one. Let's build, run. Can't turn them on, but we're okay turning them off. Consistently random, yeah. Almost makes me think that's it's because it's optimized. It's optimized this somehow. Could that be it? Do I need to turn off optimization on the build? Or set it to be volatile? I guess I could try that. It might be, yeah, I'm guessing it could be something with the optimizer. So, actually the easiest thing would be to edit to make a debug build. So, let's make a directory build debug, and then cmake -g ninja, and then dash, I forgot how to do this. -- help will help me. I forget how to do this. Anybody know? It's like, it's not toolset or generator name. Yeah, cmake is a little bit esoteric. I need to look it up. Cmake debug build. Setting, here we go. Cmake build type equals debug, that's what it is. So it's -d cmake build type equals debug. So basically, don't turn on the optimization. The other thing I can do is to prevent the optimizer from mucking with the structures. I could mark them as volatile and give them attributes to not let them get optimized away. Okay, so cmake -h build dot. This is going to take a few minutes. Usually connect directly to VS Code to the Raspberry Pi over SSH. It uses certificates for auth. That's what I'm doing. I'm connecting to it through PuTTY over SSH. While that's building, let me look and see if I might see something wrong. Okay. Knowing that if these are all 0, the variables are all the same values, what might the optimizer be doing to me? It's possible that it expanded 2 different copies of this code. So what could be different if they're made copies? The only thing I can think of is this structure, maybe. The fact that it's taking addresses of raw structures. I'm wondering if maybe I should declare this to be static. Or something. Because it's failing on this last step, right? Where it takes the address of tr. I don't know that the SpyOC message 1 does. I could look that up. I think that's the actual command number. So it's maybe that structure that I need to worry about. Oh, I'm also not zero initializing that. Ooh. That's it. I'm not zero initializing the structure. Bad. Bad, Raimu. It's just putting it on the stack, and it probably doesn't have a constructor. That's it. That's it. I found it. Okay, so let me verify this guess. I guess I can let this continue building, but I could just use another shell. Well, no. I'll let it build. Yeah, there's probably some uninitialized variable in there. I'm guessing that where the code I copied it from, that, is this still working? That this initialization technique zero initializes anything you don't specify. That's what I'm guessing. So since I didn't use an initializer, it's not zero initializing the unreferenced members. Which means there could be a member in there called self-destruct that might be being set to 1 for all I know. Okay, this is almost done. I guess I'll just let it finish. Just in case we need it. I actually don't know. It's possible that the build I was using was debug by default. No, I don't know why I'm touching the capacitor while it's on. That's kind of stupid. 134. I'm just waiting for that number to get to 141 and then finish. Bzzz. It's an extension, isn't it? Oh, when you do it from VS Code, the whole VS Code acts like it's running on the Pi? Oh, I didn't know you could do that. So I would have to have something running on the Pi to serve the data, right? I'll have to look into that. Okay, so I'm going to guess that's not the problem. I'm going to guess the problem is in the code here. Where's my VI? There it is. So where I have this structure here, let me look this up. I want to use mem0 dev docs c mem0 or memset. It's in string. Okay, I don't want the C++. I want the C. Do I not have C installed? I don't. Enable C. There we go. Memset string.h. VS Code takes care of everything. That's cool. I'll have to look it up how to do that. So I need not here. I'm doing this in VI, right? Yes. I need string.h. Include string.h. And then where the structure is set up right here, we'll do void memset tr0 size of tr. I think I got that right. It's destination character and the number of bytes count, right? Okay, so then cmake build. How embarrassing if this turned out to be the bug. Okay, it's active. I tabbed right past my window. Yep, that was it. So let's have it go back to actually. There we go. I turned on the lights. Search SSH in the extensions tab. I know I haven't done highs today, Aiden Garth, because I got my hands full of LEDs. Okay, for you, I'll do a high, because I don't want to offend you. Hi. But everyone else in chat, I have not said hi to. Just everybody pretend I just said hi to you. Okay, so I can turn them on, I can turn them off, and I can do a flashbang. Oh. Flashbang. Actually, it doesn't taper off smoothly enough. Ow. I looked directly into the lights when I did that time. How does it look like on camera? Looks pretty cool, huh? Well, grumpy game dev, I think you're just a little bit grumpy. Okay, let me check this fix in. So, yeah. Let's clean it up a little bit. I don't think we need to say this. Let's put this back to the negative condition. All right, and then let me look for printfs again. Okay, it's unnecessary to actually print something here because all the failure cases actually print something, right? So what if I just put void at the end? Because this will never fail, right? I'm tempting fate here. And then, yeah, let's just build that and test it. Maybe the finger was a thumb pointing up? Maybe. Giving you all a thumbs up? Oh, you guys couldn't see me working there, could you? Sorry about that. Still showing this screen. Okay, so flashbang. On, off. Flashbang. And I really wanted to flashbang the other color, right? Actually, did that get the color correct? I don't think it's doing the correct color, is it? That should be red. No, it's not. It doesn't have the color correct. What did I screw up in the color? The flashbang's not right. Oh, that wouldn't be this file. That would be in the LEDs. And you guys can't see it. Now you can. Source LEDs. No, I had it RGB in the URL, just to be consistent with URL colors. I do have red, green, blue there. So why didn't it work? Oh, probably because they're captured from the stack. Yeah. So let's fix this by capturing by value. Red, green, blue. And brightness we actually don't need, do we? Yeah, let's get rid of brightness. And while I'm at it, let's... I didn't need 100 here, actually. I think it would look better with 50 millisecond interval there. And then, I'm gonna guess that it did the wrong color because I didn't capture by value that. Let me see if I'm right. The Pi is thinking, oh, because I didn't update the header. Flashbang header doesn't have a brightness. And that means the main .cpp, where we call flashbang, doesn't have a brightness either. We're ignoring the brightness. Yep, build. The Pi is definitely slower than my computer. Usually my builds are like a few seconds, and this one's like many seconds long. And then run it. And then, so, on, off, and the flashbang doesn't have a brightness. And that's red, green, blue. There we go. This will never... Ski Dog, you know I always say that. This will never fail, right? That's famous last words. Okay, so... Am I done for now? I've done the flashbang. Your Pi Zero is powered by a broken rubber band and a half-dead hamster? It was like $10? Wow. Okay, I've been going for 6 hours. I could use a break. This was a good project, so I don't know if I'll do it on stream or not. Probably not, but I'm basically going to take this setup and make a condensed, cleaned up version of it, mount it somewhere, and then have the lights be controllable through Twitch. So maybe the next time I work on it on stream, it will be working on the stream helper, which will, one of its features will be to let, I guess, people with channel points play with the lights and stuff like that. So, yeah. Hope you guys enjoyed watching me assemble this nightmare and turn on the lights and all that. Let's go raid somebody. I'm gonna go eat. It's like 3:43 p.m. and I haven't eaten since this morning. Where's my... I closed my browser window. Oh, no, it's still up. Okay, good. Oh, you're welcome for the illuminating stream. Let's see who is streaming right now. I saw one quest for Simuleos. Hold on. Just gonna see. Adam's still playing a rerun. Interesting. So did he like stream for 4 hours and then decide to just show it again as a rerun? Yeah, exactly. It's gonna be like that, really, Frank. But it'll cost channel points. You'll have to redeem whatever mana. You'll have to redeem that. I guess we can raid Simuleos. Why not? Haven't raided him in a while. Simuleos is a brilliant mathematician and algorithms expert. He's like the curator of a bunch of algorithms on the web. And it says for his stream today, the climate machine. I have no idea what it is, but he's a cool guy, and I hope you enjoy his stream. Simuleos. Let me get the link for you in case it doesn't flip over. And there it is. Simuleos. I'm hitting the button. See you later, 715209, and Anakim Luke, and Ski Dog, and Really Frank, and Jebico, and Grumpy Game Dev, and everybody else. Thank you for all the follows. I hope you enjoyed watching the lights, and me not blowing things up, which was nice. Hope you enjoy Simuleos. I will see you there, and I'm going to go get something to eat. So, hold on. How do I do this? I'm going to say goodbye, and then hit the button. Ready? Bye-bye!